Oh, I don't know if we've gone live. God damn it. Do we want to just like, I don't know, where do we want to start this? We've just started nattering. Right.
I know there were a few other people who said they were going to attend. A few other X-ray folks. Alec and Jim, but I'm not.
We start this conversation with just Martin, and if other people join, that would be great.
Oh, yeah.
How does Martin feel about that? Hello, Martin.
Streaming is on.
Hello.
Hi, Jim.
Hello.
So, Martin, Jim, do you want to just both give sort of a quick introduction? Maybe we can also introduce ourselves in the room and online as well.
Yeah, okay. So I'm Martin Durant. I work for Anaconda. And for the interest of this crowd, I work on FS Spec and Intake and Kachunk and Desk and ZAR. And these are all things that you may be interested in. And I also have connections with the Pangeo group. So X-ray and coordinates and stuff are definitely of interest to me.
And Martin, you also have a background in?
I used to be an astronomer, yes. Neutron stars, so quite divorced from the sun. But,
That's great.
But yeah, I did ground-based infrared optical and also X-ray UV satellite stuff.
Whereas I have a background in neuroscience, so pretty far afield, but I got there by way of covering the surface of the brain. The surface of the Earth was not that different, and now moving from the Earth to the Sun. I work at Anaconda. I'm the head of I'm the director of the Custom Services Division. I'm also part of Pangeo, and the main intersection here is that I maintain the set of visualization tools called HoloViz, and they're designed to support large remote distributed data sets, unlike most visualization tools. And so they integrate well with Dask. They use ZAR very well. And so essentially, when you want to scale up a large multidimensional data set, there aren't that many options for visualizing it naturally without having to extract the data, copy it, make your own local version, and then view it. And so I've been working with the Panhelio group recently, trying to make it seamless to start with data that is multidimensional data that's representing the sun, and be able to visualize it within the right coordinate system with all the right labeling smoothly and having everything connect up all along the way.
Great. Okay. I have actually one quick question before we continue on with Martin and with Jim. Martin mentioned a lot of packages there, including X-ray, and I think, Jim, you mentioned one of the packages you work on, I understand, is built on X-ray. So right. I guess my question is, what sort of level of expertise would you consider you have specifically with X-ray from its, like, from a user, but also for its philosophy and maybe roadmap? How expert would you consider you guys?
I would be maybe 70% expert in the philosophy and roadmap. I'm a pretty good user. I'm not an X-ray developer, but I do have people on my team who have been X-ray developers.
Right. Yeah, and for me, I've had a couple of PRs to X-ray and delved into particularly the storage side of things there, because that connects better with the stuff that I do. And I've been following the indexing work that's been done, which is the coordinate relevant one. But I'm not on the X-ray team, and I haven't developed it much as more of the tools around it.
And there's a person on my team who is currently on holiday. He lives in Wales, though. He's the one that I'm expecting to work on the X-ray work. So you'll probably have some personal introductions later. That's Ian Thomas.
Great. Like I can go next then. I'm Dan Ryan. I am a solar physicist still, but so far so good. But also, you know, the fact that I'm in this meeting, sort of spent various amounts of my time on software development, both in and adjacent to SunPy. The most relevant thing for this discussion is one of the lead developers for the ND-Cube concept and package, which we found out this week is starting to gain a little momentum in the sort of solar community, which is great. I've used X-Array twice. I would consider myself very much not expert, but my understanding of the concept is that, you know, X-Ray and ND-Cube on a high level trying to solve basically the same problems, but for various technical and community and historical reasons, there are apparently incompatible solutions, at least for now, on that. And so, you know, both have needs to exist at the moment. So yeah, I'd be looking to just get out of this a little bit of a better understanding of X-Ray and maybe the community that's building up around that. Sounds like you two guys are good representatives for that. Yeah, and just basically, if nothing else, just better understand like the blockers and what the consequences of the solar community going the ND-Cube route compared to other communities going X-Ray. So that's my kind of hope.
That makes sense. And just to do a little bit more background, if you're doing work on brains, you care about multidimensional arrays, doing volumes of the brain tissue. And X-ray started in the geosciences community, but it is heavily used in the microscope community and the brain imaging community. And so it's already gone through a transition of trying to reach another community. It was originally written to be as general as possible, but entirely written by climate scientists, by geoscientists. And so they made certain assumptions and they've relaxed those assumptions over time. And it's actually probably an easier jump to heliophysics work than it was to the imaging community.
Right, great. Who wants to go next in the room here?
Well, should we just keep it to?
I think probably, yeah, this is scope. So Stuart.
Hi, I'm Stuart Montford. I am lead developer of SunPy and also have done a lot of work on ND-Cube, primarily motivated by work I'm doing for the Daniel Kenoi Solar Telescope, on representing the coordinate information and all the data from that facility, making use of Dask and various other things, but still stuck to ways AstroPy and the community likes to represent coordinate information. Yeah. One else? What do you want?
Well, yeah. So yeah, I'm Will Barnes. I'm one of the SunPy developers. I'm not an X-Array much of a user at all. I have been a fairly heavy Dask user for several years. But for the purposes of this discussion, I'm mainly I wanted to be sort of a facilitator between people like Stuart and Danny, who have been working on ND-Cube for a while, and then to have this discussion with the X-Ray community to sort of better understand what the frictions are between our approach to multidimensional coordinate-aware data structures and the sort of X-Array approach. But the main reason being that, and we were just sort of talking about this a bit over lunch and afterwards, there's a significant portion of the scientific Python community obviously using X-Ray, and using X-Ray plus Dask plus HoloViz for these really large out-of-core data sets. And obviously with things like the Helio Cloud being and people's desire to kind of do large data analysis, out of core, outside of their laptop on solar physics data, we need data structures that can accommodate those types of workflows. And certainly ND-Cube can in a lot of ways, but clearly the community is standardized around tools like X-Ray, Dask, HoloViz, and we don't want to lock ourselves out of those communities. So I think we want to have this discussion to sort of better understand what is the mismatch between the tools that we're developing and things like X-Ray.
So I suppose it's fair enough to say, so we're not spend the whole time on introductions. I think it's fair to say most of the people in the room and online are sort of solar physics community folks who, have done various levels of development and user in the SunPy, sandbox. I think everyone's sort of increasingly aware of NDCube and use NDCube or are interested in using it.
Yeah.
And probably, I'm sure there are some people who've used X-ray as well. So presuming the fact that they're here means they're interested to see where this future world might go, because they'll have consequences on their work. Then my last question for Jim and Martin then is, how familiar, if at all, with NDCube are you guys? Because that's probably important to know where to start the conversation.
I'm familiar
I
enough
haven't-
with it to know that what you said about what you're expecting from the interface to X-ray and why X-ray is interesting seems accurate to me. What I understand that NDCube and X-ray are in very similar spaces, but just little mismatches and misalignments that need addressing.
For me, I haven't done anything with NDCube of note, but I do know SunPy quite well and if its format. And so if you see it as a layer on top of that, then that is definitely relevant. And NDCube I've seen more demonstrated than anything else.
Okay. All right. Well, in that case, just to give a very quick intro then to NDCube. Stuart, do you want to start off with something else?
I was just going to say, I think for the purposes of this discussion, the more important thing to talk about is probably WCS.
Yeah, that's what I was going to get to.
Yeah.
So why don't you lead it off there?
I think NDCube to some extent is, it's designed to facilitate using WCS with solar, with WCS and data together, much in the same way that X-array is designed to facilitate using data and coordinates at the same time. The impedance mismatch between these two things comes from how astronomers have historically and continue to store their coordinate information. And I'm, as I said, I think before we really kick this off, I haven't done enough with X-array to know the answers to these questions I have. So this is a particularly evil and also actually very bad example of a WCS that because this one actually would fit in X-array really well because it's all lookup tables. But anyway, it was the one I had in my in my prompt history. So
the fact that it would fit into X-ray, though, I think it's fair enough to say is actually very rare.
Yeah, the reason this is in my prompt history is because I was fixing bugs in it yesterday because it never happened. So anyway, that aside, so I think there are two main things that are unclear to me if is the wrong word, how much work it would be to get X-array to support, right? I'm sure it is definitely possible that we could get astro data into X-array and it work well. The question is one of resources, right? How much time that's going to take and who would be needed to do it. So go on.
Just to muddy the waters a bit, let's distinguish between X-array as of 3 months ago, which is purely in terms of an enumerated set of coordinates, and X-array now and maybe in the next few months, which is, there's been a lot of work being done on flexible indexing in X-array, some of which is motivated directly by WCS and others for other reasons. And I can just tell you, there's a maelstrom. There's a whole bunch of people doing a bunch of work right now, and it's hard to say what is and is not supported as of today. In fact, that's Ian's main task. Okay. Get on top of it.
Yeah, I think it's fair to say that the whole point of this thrust was to allow analytically defined coordinates in X-ray as opposed to lookup tables. That is the thrust. So that there is an API in place to allow that, but as far as I know, nobody's demonstrated it with an Astro type WCS, but there's no reason it shouldn't work.
Mhm.
It's just
Right, I
a
mean,
case of getting to it.
yeah, I think, as you say, because that's so new, I had a conversation with some people, I'm going to not be able to remember their names now, at SciPy this year about this, and it definitely sounds like, yeah, it's a lot more possible now than it was in the past, but given that it's so new and there aren't much examples, or like, for somebody not like engaged with the development of that stuff, I have no idea where to start in testing it out. I'd be very up for making a proof of concept, but I would definitely need somebody with a lot more X-ray experience to like work with.
Right. So we're working with those, or at least
So,
we mean to work with them.
no, go on.
Just that we also.
What were you going to say?
I was talking with Tom Nicholas. He seemed to be my best point of contact on X-ray for these issues. He's working simultaneously on adding solid unit support, which may also be of interest to you, for having each dimension have associated physical units be well supported. He's working on that, and also on this flexible indexing. And so basically I made a note. Ian's going to dive in on my team, come to terms with it, then meet with Tom and understand the current status, try to work out where these impedance mismatches are, and then understand how big they are. Do we have enough funding to bridge them right now in our current grants? And if so, we'll do so.
Mm-hmm. So if we just for the moment magically assume that flexible indexing has solved the WCS problem, the other big question I have is, when you convert a pixel to a world coordinate with SunPy, this is some of the output you get, right? Each of the some of the coordinates are held in their own very rich SunPy objects, which can hold loads of metadata about these coordinates. Like, this is a wavelength in nanometers, but all of this is extra metadata about that wavelength. Like specifically where the observer was, what the target you were looking at, and then it computes things like the radial velocity. I swear that gave me a different number yesterday. Yeah. And like that, obviously, also for positions on the sky, there's all of our coordinate transformation infrastructure between physical coordinates relies on these SunPy objects, with information about how big the sun is, where the observer was, what the time was, and I'm just curious whether X-array has primitives to handle anything beyond like numbers out as coordinate data.
What I would say is that you can have arbitrary attributes, and those can be numbers or strings or objects or whatever you like, if the storage format that you're reading from supports them. So not all storage formats allow you to store arbitrary attributes, but presumably we would still be reading from fits here, or we can talk about Zara and other things later. But assuming we would read to X-ray from fits, you would be able to store these things in X-ray attributes, and you would still be calling the same AstroPy routines with the same set of input parameters to do any kind of transform that you wanted to do. When you select a point, then you do expect to get the value with its unit of that point and all the coordinate information that belongs to it. That's how X-ray works at the moment. This kind of thing is rare. Usually we're talking latitude, longitude in degrees or something like that, which is fairly straightforward. But I believe all of this is possible as things stand right now.
I agree. I'm pretty sure.
Just to clarify, when you say an attribute on an X-array, what is that? Is that like a world coordinate, or is that like just
so an attribute can be any
information about you?
Metadata.
Yeah, it's metadata in general, which we would be interpreting as a world coordinate. So you would have to have attributes with special names, presumably, and they would belong to the coordinates that go along with an actual array. that's the way around you'd have it. So you have your measurable array, which is, kelvins or whatever
yeah.
it is that you're measuring. And it will depend on some coordinates, and each of those coordinates will have attributes that tell you the type of coordinate it is and any extra information that you need to interpret it.
So that sounds like, to me, you're kind of, so the way it works in NDCube through WCS at the moment is sort of all that information is stored in a very kind of dense or way in a WCS object, and then these larger, richer objects are sort of calculated like on the fly based on functions or functional transformations, and so it pulls together sort of automatically some of this information and then builds it. So it sounds like what you're talking about is you're kind of breaking up or spreading out that information over a wider number of attributes. Am I understanding you correctly there?
Well, that's how they are fundamentally stored right at the moment, right? In the actual fits, where you showed some fits headers before, it's a bunch of values in a bunch of attributes. That's exactly how it's stored. And then you can build up a rich object, which is going to do the transformations for you. And in the present picture in X-ray, that would go into one of these flexible indexes, which would give you coordinate array-like operations without manifesting the arrays. But I think everything that you have here should be possible in that framework. It's just that it would take some effort to put the plumbing in place.
And you'd also have to document the conventions involved, the naming and the locations of this, so that the tooling knows what to expect. Like, it can be stuffed there, I think, right now today, I'm pretty sure. But you have to know where to look for it, and your tools have to agree where to look for it.
I guess I have a second question as well. So you mentioned, I'll ask that first. You mentioned at the start that you were said, okay, assuming we're reading from a fits array, why was it necessary to make that distinction? Why are you thinking about tying to fits? In principle,
the only reason is
we could do this with no data type. You could build it in Python with no file. That's
sure.
Yeah.
possible.
So fits is a place where there already is a convention for how these different parts of the WCS are stored in particular keywords. That's the reason. So if you were storing this in HDF file instead, then there is no such convention. There are other coordinate systems in other fields that you could, like, there could be a field called affine or something, depending on what the use case was, but that's not good enough for this. So probably we would stick with those fits conventions of the CR, CX, whatever header keywords, because that's what we have. Even if we choose to store it in a different format, we'd probably use exactly the same keywords just because the convention already exists.
Okay, so to just mention a little bit more about how the direction NDCube has gone with this, is NDCube has become, strictly agnostic to fits. It doesn't care about that. Like I said, you can build up the WCS objects in Python, like manually if you want. There's no actual intrinsic link back to fits. And so the idea is you have an array that can be NumPy or Dask or anything really that quacks like an array. And then you have this WCS object that can be built from a fits header, and that is a well-trodden path, but doesn't have to be. Just any object that what Stuart just showed on the screen there, this WCS API convention. And so you're only dealing with these two sort of Python objects, the array and the WCS. So it sounds like the way you are describing it, at least, is this would be a step back towards some more file-like convention of storing the metadata and then sort of building this WCS object. It's kind of
no, I don't think so. I don't think so.
Right.
I was just maybe operating under the assumption that you were following that well-trodden path, but there's no reason to have to do that. The flexible index that we're talking about on X-ray would have its own internal state, which would look, well, it would probably use exactly the same WCS object, actually.
So we
Use
could
the
just,
same.
sorry, but just saying, so we could actually just like have an AstroPy WCS object and attach it in an X-array object. Is that right?
Yeah, so you would have an
Right.
X-array WCS index class, which is yet to be written, which would hold a WCS and expose the API that X-ray expects for an index. That's how I imagine it working. One of the inputs to build one of these would be a FITS header, but
Yeah,
there'd be other ways too.
it's worth thinking about the history of X-ray here, which is it started with the NetCDF data model. It was designed around that, but it abstracted it and it became only about what's in Python's memory. In no way was it tied to NetCDF, but it was designed to exactly support that way of describing things on disk. And nowadays, X-ray is used by lots of things. Lots of people who've never heard of NetCDF, they use it, they're happy, it works fine, but it's designed to capture everything that was in that file and nothing is lost in the translation into X-array. And I think it'd be similar for FITS, is the idea that whatever FITS can express, you should be able to express that in this in-memory or out-of-core data set, data structure, so that it's, you mention FITS to make sure that that's all represented and you follow the similar conventions, but in no way does it depend on FITS or is tied to FITS.
Yeah, that does sound like a similar path that's been trodden, not only by NDQ, but by a longer journey that has brought us to NDQ. Yeah.
So it sounds like this, it sounds like with the recent changes to X-array, this has gone from being a massive project to being actually tractable, which is amazing. I know that like Anaconda's a bit involved with doing this. What's the current status of like this effort, and how can we, as NDQ maintainers, get involved?
So, go ahead.
I think it's more fair to say that we've been cheering this along and hoping for its success. We haven't really contributed to it.
Yeah. So the mystery there is that I met Alec Engel of NextGen Fed about 3 years ago, and ever since then we've been chasing possible grants to do something like this, so that our visualization tools can be available to this community. He's already doing it in his own work, but it's very painful to convert things from their native thing into something that our visualization tool supports, like Data Shader. And so we've had this idea, we discussed it, we agreed, he's applied for various grants. The various things have been funded, but not exactly that. And finally, we got one funded recently from NASA, a very small thing. And so it's just kicked off a few weeks ago. Martin's on that and I'm on that. I'm not doing any work. I'm just the leader of a bunch of people who do the real work. So when they're embedded in it, they'll be much better people to talk to than I am. But we're looking forward and we're coming to terms with what happened over those same 3 years. Other people with the same interest have been pushing things and they've gotten pretty far, but it's clear that they haven't gotten necessarily all the way, or at least if they did get all the way, it's not visible. And so that's where we are. We're ready to dive in. We don't know if we have how much work is left, and we're very interested. We wish it were all done in the past because we would just like to use it. If it isn't, we're going to see what we can do.
Okay. I mean, so I'm both with my SunPy and my AstroPy hat on. I know that there are a lot of people who really care about this, and I'm very happy to, I guess, represent both the AstroPy and the SunPy community in this discussion. If you've got effort on the topic, like, please feel free to reach out, and I'd be happy to work on it with you. Like, if you are going to start pressing these buttons. Basically, what I would need to do to be able to prototype this is I would need somebody to come along and tell me how X-array works, right? Like I've got the AstroPy WCS stuff down much more than I'd like these days, and but I mean, there doesn't seem to be, or last I checked, it's been a couple of months, there doesn't seem to be much documentation of the flexible indexing stuff yet. It was still exceptionally new when I was looking at it, so I have like no hooks in where to start myself at this point.
Yeah, I think it takes going to the one or two people in the X-ray core that understand this and say we have, you know, a real strong use case for this, which I'm not sure that they have themselves when they came up with this, or maybe they are just thinking of affines or something that's fairly simple to express. And having a sprint, actually, you know, sitting down and trying to see how far you could push it in a limited time frame.
Yeah,
Yes.
that'd be amazing.
And I didn't hear who was talking. So who's volunteering themselves to sort of work with us on this? We would, whoever that is, that's great.
Stuart Mumford.
Okay. All right. So from my point of view, when Ian Thomas gets back, which is in another, I guess he starts on Monday, comes back on Monday. So he's going to dive in, come to terms with it. And then I'm going to talk to the X-ray people, starting with Tom Nicholas, and then we'll have an idea of some idea of what we're doing, and then we can reach out.
Cool.
Then a question I have, which is a little bit less on the collaboration, but sort of just more just trying to understand. My understanding is X-Ray's API is actually quite flexible, or not too tied down when it comes to like naming conventions and so on. Like earlier on, I can't remember if it was Martin or you, Jim, who was saying, you know, you can have these attributes and you can call them whatever you like. You know, which sounds like quite powerful in a way. But when it comes to what we're trying to do with NDQ, is we're trying to be very minimalist, but also say, right, these few things are named this way, are accessed in this way, which then allowed us to sort of define a minimalist API, but a reliable one nonetheless, on which like the community can build. So with that understanding in mind, could you correct me on that, or ask the subsidiary question, which is, would the move forward then be that actually we could move ND3 to being depending on X-ray, and ND3 then becomes like an API defining wrapper for Solar and Astro, but you know, the deeper things it'll just do in an X-ray way if you wanted to.
That
I'm not clear on
sounds
that.
good. Are you familiar with the CF conventions?
I'm not. No, I don't know if you
No,
are.
nobody here is, of course. This is
Okay, so basically, as I again, I'm a brain scientist. I don't know anything, but as I understand it, that paired with X-ray is a set of conventions for how you assume coordinates are arranged, what you name them, what you assume about them. If your data follows that, then all sorts of tools can understand that and use it. X-ray itself in no way enforces those conventions, but it is an agreed upon document or standard that people strive for and mostly fail. Like apparently it's very hard to reach.
Right.
Yeah, well, CF
Yeah.
is specifically designed for Earth science. So Earth observation and climate, weather, oceanography, they all use this. It's not a convention that would be applicable to us, but you effectively already have a convention in the set of specific parameters that you use. So that would be a parallel thing that X-ray can support, or if ND3 is, like you say, a wrapper on top of X-ray, then X-ray doesn't care and just exposes these, and ND3 then takes the same things and works with them. Either of those, I think, is tractable.
Okay, so it sounds like, assuming the best case scenario, that, you know, these recent changes to X-ray could solve all these problems, and it's just a matter of doing it, and the doing it part can be done in a, you know, reasonable time frame, whatever reasonable means. It sounds like there may well still be a space for there being an ND3 object, but that if it's built on X-ray, then if there's some routine that just worked on a generic X-ray object, then it should just work on an ND3 object as well, because underneath it's just X-ray. And that sounds, if that is the case, that sounds like it could be very powerful, because you could have the best of both worlds.
Yeah, there are precedents for building on top of X-ray objects. The one that springs to mind is multi-resolution imaging, where you have a very high-res thing that you don't normally want to touch except for your final analysis, and then you have downsampled versions of it, but they all live within the same data structure and the same coordinate space. So viewing them together is not something that X-ray normally does, but there is a package that Jim probably remembers
Data
the name
tree, I
of.
think it's called.
Yeah, okay. That builds on top of X-ray and provides that extra functionality.
It has assumptions about the relationship between these multiple downsample things that otherwise would just be a bag of things in the same file or the same structure. Like, oh, okay, they actually have this certain relationship, and that's essentially it's a convention. But if you follow that, then you can use it a certain way.
What was the name of that package you said?
Data tree. Same guy, Tom Nicholas, I believe, is involved in that. So he's the either the weak link or the nexus for a lot of this.
Both of one? Yeah. No, I'm actually quite excited for this. This sounds like these things could be a lot.
Q3.
Oh, yeah, no, it sounds like no, it sounds like it could be a lot more complementary. Like I wasn't exactly sure, but it sounds like these are a lot more complementary than competitive than I thought it might be the case. But ultimately, all that matters is like the users, so long as they have something to do their science, that's where we want to get to, right? And do that in the best way possible.
Yeah,
I think from our side, we still have a lot to learn about X-ray in terms of building on top of it and figuring out like what the user expectations are and
and how much we want to build on, how much we just want to take and drop.
When you get into interesting things that are challenging for us at the moment, like slicing and like when you start reducing dimensionality of the WCS object, can you continue to carry that around, and how do you go about re-serializing that once you've modified it? And all of these questions are gonna,
I mean, this could be like a long, potentially, depending on how long these sorts of like this Python specific scientific ecosystem lives on. But this could be like a long-term project where these two things like coexist and collaborate, but maybe they slowly come together by moving stuff or upstreaming stuff to X-ray or something. But it's probably going to happen over AstroPy, but that might happen over a long time. And there's a space for all of these things to work together rather than compete.
Yeah, it's definitely worth making the point that with data volumes being what they are, the traditional model of you downloading your 1,000 FITS files and processing them locally is not going to be a way forward. So we, like NDCube is a vision of how to deal with a whole load of those, leveraging Dask or whatever, but eventually the whole ecosystem will need to make this transition, I think. So it will always be possible to load all of your data into memory if you take a small enough part of it, but that's not going to be enough to solve big science problems. So this is, again, the Pangeo and X-ray have had to go through this, and Pangeo is a showcase for doing climate science in the cloud, where your data lives in the cloud and using Dask to parallelize and like the visualization tools and all those things. And the reason is that this transition perhaps came a little bit sooner for that community, because high resolution Earth imaging, has been around for a few decades. And so, for example, there is a PR that has taken an impressively long thread and time to be merged, and it's not yet merged. It's now finally waiting on me to get FS-spec support in the FITS loader for AstroPy. So that's something that kind of thing, to be able to load your data directly from source rather than download it onto a disk, which might not be able to hold it all, is very important for pushing things forward.
I think there's a lesson in that for solar physics. I think we're in a strange scenario where we have gone into that world with missions like SDO and instruments like AIA, where we are in the big data world. But we may be moving away from that, oddly, at the moment with like a lot of like missions that are going beyond Earth orbit, and so we're kind of, I feel like we're
yourself, space boy.
Well, sure. No, but I'm saying we're in this strange sort of like dual scenario where we kind of have a foot in both camps. And one's not going away, for the other,
I think we've also, like, even with SEO, we've entered into this world of very large data with really at least the Astro specific tools to really deal with that data. Like a lot of our analysis tools are still predicated on the assumption that everything lives on disk and everything, my data set is composed of a single file or maybe a few files, not 100,000 files.
We've significantly underutilized our own instruments, I think.
Yeah,
because of that.
Yeah.
Yeah.
Yeah, and now we're building up the infrastructure, like the computing infrastructure to do that, but I don't think we have necessarily the software infrastructure yet to actually be able to make use of the data plus the compute.
Yeah, and to be sure, the earth science community is the same way. It's just such a large community that the Pangeo portion of the earth science community is actually a sizable enough community, and it's been able to get this together. But the earth science community is basically the Pangeo folks and people associated with them who are easily handling large volumes of cloud data, processing it remotely, visualizing it, and their lives are fine. And then there's a much larger community of people with older tools and different approaches that don't do that. They don't attempt to it, or they do it in a way that's localized on certain high performance computing systems, where for that, when you're running it on there, it is local to you. It's no longer distributed in cloud. It's part of a coherent unit. So basically, there are three camps: the ones who are unable to deal with the volumes at all, the ones who only deal with it in a centralized HPC facility, and then the Pangeo folks who are very flexible about where data might be located and how it might be processed.
So I think the lesson I take from solar physics sounds like it's very applicable to that scenario, which is that we have to support all three. You know, with these generalized tools, we need to be able to support all three, because we're going to have those people looking at very different types of data to achieve very complementary and similar science goals. And they're going to need the tools to seamlessly switch back and forth between those models.
Yeah, so Python and Dask does lend itself to that way of thinking, because it has low overhead on a single machine, but is still useful, and it runs on HPC and it runs in the cloud. Some more specialized software that has been around, like MPI-based things that only run in the HPC, then you can't use elsewhere.
This might be another part of our pitch, is to, why SunPy, why Python for solar physics.
Indeed. Yeah. Scalable tools. Use it on your laptop, use it on an HPC machine, use it in the cloud.
Yeah, we have listed that before, but this kind of emphasizes it. So
yeah,
that's interesting.
Yeah, and it's hard for us to remember that those are some of the reasons we're in this space, because we're in fact just dealing with lots of technical problems all the time. But the whole motivation for any of this is exactly that, that flexibility and that ability to scale and tackle large problems economically. And it's like, oh yeah, that's why we're doing this.
Yeah, absolutely. I think that answers all the questions I had anyway. Is there any other points on this we want to discuss, or are there any questions from the room or online? No? Okay.
Stunned into silence.
Yeah. Was there anything else you want to raise, Stuart? Or Will?
I don't think so.
Yeah. Were there any other questions from you guys, like Martin and Jim?
Not at this moment. Pretty much I'm trying to not learn too much myself and let the people who actually have time to work on it do the learning. So that'll happen very soon.
That makes sense.
I have one thing I could tentatively raise if you want to indulge me. I have a project that I've been working on for a while called Kachunk, which does it's a way of indexing a set of input data files such that you can present their pieces in an aggregate logical file as a ZAR data set. That's the current model. And so a lot of the examples that we've had is you have a bunch of NetCDF4 files, HDF5 files, and you could load them in X-Array, but it's a bit painful. Maybe you have to download them all to get decent performance, that kind of thing. So if you first index them and you build a metadata and you save that metadata somewhere, now you can see the whole thing as a ZAR data set. You don't even need the HDF library to read them all at all, because basically all of these things just store C buffers somewhere in the file. So if you can find out where that is, then you don't need the target format specific library to load them. So what Kachunk does, it gives you remote and parallel access to all of the original files, and you can view it as a single data set, and you can do slicing on it just to get the specific parts that you need, and it plays nicely with Dask and X-Ray. So that has garnered quite a lot of interest particularly in the people that already know about ZAR and NetCDF and similar formats. But it also applies to FITS, because FITS, again, just like everything else, just has its data stored as an encoded C buffer and a bunch of attributes to tell you what that thing is. So I have one example, and we'll be building more examples of taking a whole load of FITS files and providing a single logical dataset view over the whole thing so that you can slice it and pick out just the parts that you need, and they're downloaded on demand from remote. You don't need to have a copy of the dataset. It's kind of interesting, but it's a little bit out on its own, unused by anyone, unless SunPy can actually read ZAR or some other integration of these things is done. So I just wanted to let you know that that was a thing, and if anybody's interested, you can look into it. It's called Kachunk, and there are some examples there that are all sort of sciencey based. The complexity for astronomy or helio in general, again, will be coordinates, because whereas the Earth science images tend to be quite nicely gridded, and you get many files because you have a time series, and the time series is also nicely evenly spaced. In Astro, often you have every single. Sorry?
Everything, just the concept of having a large data set where everything's on the same grid and evenly spaced is like just so nice. Like it just
yeah.
Never have evenly spaced
I mean,
files for some reason.
yeah. I shouldn't say that it is actually on a grid and evenly spaced. I should say that the pre-processing happens before the archive is saved.
Yeah.
a
lot of
Yeah.
Yeah, so that's because
Yeah,
I mean
we don't get
these
that.
are real satellites taking real images, so they are all over the place, but we never get to see that.
breaks of everything.
The climate models are always on a nice grid, right?
Sure.
So yeah,
So
there is
sorry.
definitely added complexity for the Astro case. For SDO, maybe there isn't, because it's pointing the same.
Oh, they're not all on the same grid either. Don't you worry.
They're pretty close as far as I could tell.
So to just ask a question about that. So did I understand correctly when you're this Kachunk is like you can search and extract a region of interest, like space, time, whatever or whatever axes, maybe not coordinates the right word, and effectively slice your files down before you actually have to like grab the files.
Yeah,
Because
so you're limited to whatever inherent chunking there is within the file. So if FIT supports internal compression, although it's pretty rare, you wouldn't be able to just read part of that of a chunk. You have to read whole chunks, but in principle, you can just get the stuff that you need to within some limitation. It's more the more important part is only accessing those files that you need. So there'll be, if you have thousands of files that form up some kind of big grid, but you only want some of those, you could use an online interface to search and cut out which of these actually meet my criteria, or you could just get the global dataset object and act on it and get the same thing without any intervening service needing to help you.
So if anybody is interested, you could look at the ZAR and think about the conundrum or the challenge that people in the earth science community are having, which is that, wow, it'd be great if all these data sets were available in ZAR format, because then I could run 100 independent or 1,000 or 1,000,000 independent processes, each accessing each chunk that they need. And if I want to look at some small area of space over time, or some small area of time or space, whatever it is, you can have efficient access for that. If only everything were in ZAR format. And so you get people who are creating these large data sets in ZAR, and then you have everybody saying, well, wait a minute, now we have 2 copies of everything. And what Kachunk does is say, well, let's just pretend it's ZAR. And can we make it happen? Can we make it be as if it were ZAR? And it turns out in many cases, Martin is amazing and can make that happen.
Yeah,
So
if the original layout of the data is something that is amenable to ZAR's model, which again, with the coordinate things makes things difficult, but I've only had to deal with data sets like that so far. So maybe there is a way to fold in coordinates into this too.
I'm very happy to drive this conversation off the rails for my own personal benefit for the next 2 hours, so stop me at some point. Martin, you proved I have basically written my own version of Fitz-Kachunk for DKIST.
Say you're sorry.
And that's a good thing. Yeah, Kachunk wants to be able to handle lots of different file formats and say all of them look like ZAR or all of them look like X.
I think based on our conversation on GitHub in the last couple of weeks on that AstroPy proposal issue, PR thing, I think you might know where this is going, but obviously for our data at DKIST and for the AAA data, we're going to need tiled compression support in Kachunk, which there isn't at the moment, right? You can read binary table, but you can't decompress the tiles.
Yes. So viewing the individual compressed chunks as ZAR chunks is very doable if only we can implement the compression codecs themselves in Python.
Yeah, so that's
for the only file that I've seen so far that actually has this, it was a rice compression, which only exists in one IEEE paper that I don't have access to.
It's not the actual raw algorithm definition. The CFITS.io library is public domain and has an implementation of rice decompression for what it's worth.
Yes, that I did see that, but it looks quite long.
Yeah. So that AstroPy proposal that Tom Robitaille and myself put together, our plan is to re-implement the tile compression algorithms in AstroPy so that AstroPy can stop relying on CFITS.io for them. And then at that point, Kachunk would be able to use them. I have one question around Kachunk and this in general, and this is just like I think my ignorance, but I think it might be interesting for others as well. Why does Kachunk? Not why. What about loading a ZAR dataset over just generating a Dask array? Like, what does that give you? What's the difference between Kachunk just here's a Dask array where it accesses the data underneath and ZAR? Like, what's the difference between those two layers?
They map one to the other very well. And there's a reason that I'll start again. So they map one to the other very well, and there's a reason that ZAR has been popular with the Dask community because it's simple and it essentially just generates a Dask array from its contents, and that makes it very convenient in this sense. It also comes with it's a logical set of arrays that link together, again in a way that X-ray likes. So we have coordinates and you have variables and they mention each other. So it's more than just one Dask array. The downsides of using, well, I mean, if you weren't using ZAR, you would have to actually generate your Dask array, right? You'd have to have some code that builds up that graph in some way. So we basically rely on the ZAR machinery in Dask to do that rather than to build our own. Nice. The downside to it, there is one feature. So I said that the ZAR expects its chunks to be a regular grid. In Dask array, you can have chunks that are you have chunk sizes that along each dimension don't have to be always exactly the same number of pixels or voxels or elements. So you could have along X, you could chunk 10 and then 20 and then 10 and then 20 or something like that. In ZAR, they always have to be exactly the same size. So that's the limitation of ZAR that Dask array does not have, but it's something that could be changed in ZAR and I've been advocating for. So then you would have all the features of Dask array in ZAR. That's still not very flexible, the Dask array's ability to do that, because you only have chunking along each dimension. So your individual chunks have to, they're always parallel pipettes. they're always somewhat regular.
Could I bring us back briefly to X-ray? This sounded like a great conversation, but I just wanted to get this question in. Unfortunately, we just lost Jim, but the question was about the ecosystem sort of around X-ray, the various packages that depend on it. I just want to get an understanding of what that environment might be. Is it that like X-ray holds the data and then also provides a lot of tools for analyzing that, like resampling, and so on. And then there's like this sort of halo of packages for like visualization, for reading things into X-ray. Or is there like an ecosystem of lots of different packages to analyze like X-ray in various different ways, and X-ray just provides mainly this sort of basic data class that then anybody can use and build their own analysis tools as they see fit. Are you able to answer that question?
Yeah, I think the comparison I would say for the standard Python ecosystem is between NumPy, which does provide, it provides a storage memory object, and it provides a whole load of things that you can do to it as part of the basic package, but it's mostly used by other packages. Like a scientist might directly use NumPy functions some of the time, but it's not going to be all that they do. As opposed to pandas, where pandas, again, is a memory storage object and a bunch of things that you can do to it. But most people that use pandas only use pandas, even though there are a whole load of other packages that depend on pandas and do interesting things with it. I would say between those two, X-Array is more towards the pandas model. There's a lot of functionality that's built into X-Array itself, and a lot of people can get their work done using X-Array alone, but there are a lot of other domain-specific packages built on top of it.
Okay, that's interesting, because I think on that 1D spectrum, ND cubes is actually more towards the NumPy end of that. So that's also interesting to just try and understand the roles that these two things are trying to play. Okay. So that's like, so basically X-ray, in X-ray's local solar system, X-ray is a very, very big star that sort of like, takes in, like it dominates sort of that area, whereas maybe NDQ or NumPy is like a kernel, around which a lot more is built, and people don't necessarily directly use that core part of that.
Yeah, I think that's fair. I mean, the difference between those usages isn't that big, but I think the emphasis is a bit different.
Yeah, and I guess it depends, like it also defines like, your scope and, just how you're in practice going to develop and maintain.
Yeah, I have to step away anyway. Okay, thank you, everybody.
Yep.
Yeah,
thank you very
so
much.
Thank you, Martin.
Yeah, thanks a lot.
Oh, I got to tell you, if you need a month of my time for this, you have it.
Okay, cool.
Shane, did you have a comment? I think I saw you unmute.
No, sorry.
Okay. No problem. Well, yeah. Sorry. Yeah. Are there any, having heard that, are there any comments or like even just questions about what in God's name just happened in the last hour? Either online or in the room.
All I have to say was that was very potentially positive.
Yeah.
I got that impression. At SunPy, we got that impression off of the X-ray people that they basically had fixed it. Like, I mean, there's a lot of work left.
Yeah, it sounds like the timescale for this.
Your question about the like restricting X-ray APIs, I think, sure.
Yeah.
One we probably would have to do, at least on the high level, and then if they really want to get access to the API, we're allowed to. But
yeah, I mean, I could see .data on NDQ becoming an X-ray.
Right.
All the time.
Yeah. But yeah. No, I
it's going to get. you're going to get circular reference nastiness going on between like attributes on X-array and ND-cube and back again, but we'll figure it out.
Yeah. So I guess ultimately, like, this is a question for the two of you. Do you think this is worth pursuing?
Yeah, definitely. I don't have a lot of time to pursue it,
Yeah, that's true.
but I mean, I'd like to see a prototype of this, right?
Yeah.
Like, I think
Yeah.
going from nothing to something would be very informative. And then, I mean, I think to move to the joke of ND-cube 3, I think we're going to need, like, whoever is working on that is going to need to understand X-array a lot better than certainly I do at the moment.
Yeah.
Like, really going to have to dive down that rabbit hole, and that means a lot of time, and I don't
Right,
have
okay.
a lot of time.
Okay, so we're going to need another effort, like we would do a 2.0, where to make this happen, we're going to need people who dedicate themselves to doing it.
And I don't have the same motivation I had to make ND-cube 2 happen, because ND-cube 2 works for deepest data. Like, that's what.
Yeah.
Ultimately, that's what I've built it to do, and it
Yeah,
works.
yeah.
And the data center aren't going to fund me to write ND-cube 3 just because, yeah, X-array, that's not happening. So,
But I mean, but like we've talked about with roadmaps and not putting like target times.
yeah, I'm just trying to like
You
set
know,
expectations, right?
Oh,
Like,
yeah,
me
yeah.
and you spend a lot of time on it, on like ND-cube 2, and this is an effort of similar magnitude, but you know, it doesn't have the same level of support at this point, right? Like,
Sure.
Yeah.
What
But
are
no,
the use cases that you can think about at the moment for this?
I'm honestly not sure. I mean, other than like all the visualization tools and stuff that depend on X-array.
I think the visualization tools and the kind of first class DAS support that comes with having things in an X-array data structure would be, those are the main advantages I see.
Yeah, I see a philosophical one, and that actually comes down to the philosophy of ND-cube, which is interoperability, right? The whole point was like, oh, we don't have a map, or we don't have like a specific instrument data object. We have something we can all use. And ultimately, if we don't start becoming interoperable with X-array, then we are doing the same thing on a larger scale, but we're still saying we're over here with like maybe with Astro. But you know, if we can just leverage stuff that people build either for big data handling or for visualization or something for geoscience, you know, why would we like say, oh no, that's not for us, when there's no reason it should be?
And also, I think like people inside of solar physics are already wanting to /are using using X-ray to store things that we would probably tell them to put in an ND-cube, but they're saying, well, you know, look, X-ray has the support of like, you know, the entire scientific Python ecosystem. Why would I not use that if I'm not particularly concerned about whether I have like an XY, you know, Cartesian coordinate system instead of a WCS? Like,
Right.
Yeah,
A lot of people are doing that because they can pull out their like, you know, they can turn a WCS into a grid.
Or even they have gridded data already, which
Right.
doesn't have a WCS, right?
Right.
Like the multi-dimensional time series stuff.
they've just
I think
some AIA maps together, and they're just assuming that everything's Cartesian in there.
I think, yeah, it's the drive for that seems to be like performance, like what
Some of it's
performance and familiarity.
Some of it's simplicity. It's like WCS is too hard for me to work with. I know I have an array of coordinate values. That's part of it, or certainly has been in the past.
so I mean,
But there are other.
yeah, the other thing I think is at the moment ND-cube just supports WCS, right? Lookup table coordinates are weird and took me ages and they're evil.
But it doesn't. Like
It does, but they're gross. And X-array obviously has like first class support for lookup table coordinates from the beginning. So I think like at the moment we're in a situation where if we got multi-dimensional time series support, you would really struggle to justify not using X-array as the base data object for that. But then you end up in a weird like situation where if you've got a WCS, you're using ND-cube, and if you don't have a WCS, you're using X-array.
Yeah, like we don't want to present that dichotomy to the community.
Exactly.
In our interoperable ecosystem.
But we are like, unless someone comes up and says, right, then we'll spend like over a year, like solidly siphoning off my time onto ND-cube 3, that's what we have. And that's because of WCS. I mean, that's.
Yeah, well, I mean, we work. All this excellent work that X-Ray have done to support NDQ, like WCS in X-Ray, did not come in time for me.
Yeah.
Right? It didn't exist, and I wasn't about to do that. So,
right.
yeah. Practically speaking, there was no alternative. But I think, yeah, long term, this is like it's only a good thing. So it's only a good thing if we standardize out more.
Yeah. But what I take from this is that it's not a case of like, oh, people should stop using NDQ because the whole API is going to change and it's just X-ray. Like to me, it seems like, you know.
I think NDQ will always continue to exist, even if it is a strict wrapper over X-ray.
Yeah, absolutely. Yeah.
I mean,
And from a user point of view, that's all that matters, really. You know.
Yeah, I don't think you're getting reproject 2 added to an X-ray object.
No.
Yeah, and
Right.
and you're also not getting the advanced serialization, deserialization stuff that the Astro people are going to need in X-ray. I would imagine. I don't know why on earth they would take on maintaining that. So
Yeah, and I wonder if there are some other like WTS specific like handling and AstroPy object handling that may well be done at the ND cube level.
things. But it could be, for instance, things like Axis World Course may just continue to exist on NDQ.
Yeah,
that makes more sense.
That's exactly the thing I was thinking about. Yeah. So.
Maybe it's already said, but like even at a minimum, you want to easily translate between the two, like NDQ to X-ray, X-ray to NDQ.
Issue 222.
Yeah. I think he might actually be writing the number.
Oh no, I've got it on. Right, yeah. I'm writing a comment.
Oh.
Too excited, right?
Yeah.
Yeah.
Okay.
I've added this to my list of SunPy projects that could be funded.
Yeah, actually, that's a good point. Yeah.
Which I'm gonna
I mean,
write up tomorrow.
I think
this is also, to be clear, there is a lot of Astro interest in this. Like we as the solar physics community do not have to do this on our own. Like AstroPy have more money and they care. Like
this is not a SunPy specific problem. This is a larger.
It never was, but didn't have the motivation. The motivation was in solar to start this, but specutils are using this. The ND cube, the Mark for ND cube is now clearly transferred beyond solar. Now, it is Astro in the inclusive of solar sense.
Well, this is the thing, is that when we were at SunPy and we spoke to the Space Telescope people, their next follow-up mission is going to be beaming 600 gigabytes of data an hour or something. That is the estimate. And they don't want people done everywhere. They want people to use that in the cloud, which is why ZAR, for example, Aztec and ZAR are talking about.
This Roman
Which is why arguably one of the successes of NDQ 2.0 isn't necessarily implementation, it's the SEP that defines the API.
Yeah.
So we can, if we believe that that is the way that solar physics and Astro need it, then we can rip out everything underneath it, replace it, so long as it adheres to that API. As far as user concerned, it doesn't break everything. So my hope would be that it would end up that SEP would be largely sufficient, and no matter what we do with what happens to the implementation underneath, that only just improves users' experience. There's no negative downside to it apart from developers having to sweat blood and tears, to make it happen.
I could well envisage a scenario where the .wcs property on NDQ is a reference to .data something .wcs. Like the WCS on the NDQ object is just stored inside X-ray, and we just reference it out as we need to. Right?
Yeah.
And that would work.
I took a lot of notes during that,
But thank God, because
and you should probably skim through them and make sure that I'm represented. So a lot of this is over my head, so make sure that I represented some of the discussion accurately.
Okay, sure, no problem.
I think that I didn't listen to everything, but I think the bits I did listen have solidified the decision not to jump and make time series AstroPy time series.
It does end up that we can use X-ray for the multi-dimensional time series, and NDQ is based on X-ray, then
Yeah.
jump in, right? And it's all the same.
So yeah,
base, underlying
I
base.
think the big stumbling block there will be AstroPy time support.
yeah.
Yeah.
So I was going to say, I think the two things pandas don't do are units and leap seconds, and it sounds like
Yeah, I forgot to ask what X-ray units were going to be. Are they fine?
what?
Yeah, X-ray unit support will be / is pint.
Okay. Maybe all units should be fine.
Yeah, you ain't
Anyway.
winning that argument.
But anyway, it sounds like units is sorted, and there is a discussion to be had around leap seconds and time scales.
AstroPy time has more advantages over
Yeah.
daytime than
Yeah.
just
Blow it out
leap
of the water.
seconds. Leap seconds is the one that likes to creep out of the bushes
Well,
and slap you around the face, but the others exist as
What
well.
other advantages are there? So leap
Accuracy.
seconds, well, time scales, accuracy.
Accuracy, like
But are there solar physics data sets that require that accuracy?
with the X-ray timing stuff,
Say pulsar timing,
the
you can tell
X-ray
that.
event stuff might do.
Say radio stuff definitely likes high time accuracy.
How high is high? Like,
Okay, like for images, it's like about 1/10 of a second, but for dynamic spectra, it can be whatever hundreds of milliseconds.
hundredths or
Yeah.
100?
Well, you can get down to 5 nanoseconds if you really want.
Okay.
Yeah, there is an important difference between those two very similar sounding words.
Yeah, okay. Cool, I will add that.
Also, like that, just the point I tried to make with the example of the world to cause thing, I had not considered the fact that I just loaded a tab file. That was very funny. Anyway,
This is a terrible
the other thing that is really important for solar and astro people is the rich metadata, the rich objects that AstroPy has built, sky coords, spectral coords, quantity, time, all of those have been around long enough and adopted wide enough now that they're all absolutely irreplaceable everywhere.
And then again, like with the way that solar is currently going, might go back to like we have different satellites across like solar system. Those tools, it's no longer it's much harder to get away with just assuming Cartesian grid and assuming like that the satellite never moves. Like, in order to like make these pretty pictures, this sort of stuff is essential.
Even from a planning point of view, you couldn't work out, you couldn't plan a mission. So you couldn't plan multiple instruments and different missions at the same time without.
Observing campaign,
So,
People love multi-instrument studies are the way forward. Like,
Right.
You're hardly ever going to see someone write a paper with like a single instrument, or it's less
you
common
will,
these
but it's
days.
like it's launched, like, and then there'll be like a burst of single, and then like the rest of the entire lifetime of the mission is going to be
Mining the data archive forevermore. Yeah.
right. Yeah.
Even context, even for instruments, let's say instruments for paper.
Actually,
There's
right.
like NAA or like
Yeah, you use AAA as a chaser context.
Yeah.
image.
EUV will live forever simply because of that.
Yeah.
Like, what new science are you doing with it? Like, basically facilitating everybody else, if nothing else.
Another one of the reproject PRs got merged again.
Slowly but surely.
Slowly but surely.
Talk about a mammoth effort.
Yeah, I mean, this whole X-ray stuff excites me and terrifies me in equal measure. So much effort.
They have a nice website.
Yeah, their docs are really nice. We should do our.
What are you saying?
What?
Rude.
I mean, NDQ does.
We are going to be using the base theme for our refactor.
Yeah, that's Sphinx book.
We'll be using what?
The theme.
Oh, right.
Oh, very nice,
Okay.
okay.
You mean
Yeah.
not Sphinx PyData?
This is X-ray Sphinx book.
But we're going to be using PyData.
No, we're using Sphinx book, which is based off PyData. PyData.
Much like Sphinx, much like Jupyter book in general, it's something but better. In this case, the theme but better, and also Sphinx but better.
Better Sphinx is always good.
What's the difference between Sphinx book and Sphinx?
Sphinx, not Sphinx. Okay, sorry, that was not clear.
What's better than Sphinx?
Jupyter book. Jupyter, or executable books in general, but Jupyter is now uses Sphinx, and they have made it much nicer to use Sphinx. Like if you're starting off fresh and you want Sphinx documentation, and you're not a crazy person who's learned the insides and outsides of Sphinx over many years, you probably want to consider using Jupyter Book instead, because it's using Sphinx underneath, so you can do API documentation and all the other stuff that Sphinx can do, but you don't have to interact with the Sphinx thing. It's marked down by default. Like you get a nice YAML config file, not a weird conf.py file. Like there's loads of other
Someone
things.
who's spent no.
I qualified my statements with if you don't already know the deepest depths of Sphinx. Like we're not moving over anytime soon, but like if you're starting afresh, it's worth looking at.
Someone who likes LaTeX.
We might though.
Yeah, exactly.
Yeah, I rethemed all the Fiasco docs to be based on Sphinx book, and they look so much nicer. So much nicer than the base one. I tried the PyData one, like out of the box, and it was like,
Is the X-Arrays thing the same thing we use, or is that a different plugin to get those nice boxes? What are those nice boxes?
Bootstrap 5, I think.
It's nice.
I think we should
They
figure out.
use Bootstrap, they're based on this. So they're refactoring no one cares, but
Nabil has gone down this rabbit hole, and now we're all about it. Let's go.
Someone turned up and wrote a Sphinx Bootstrap template thing, which has all the bootstrapping, all the JavaScript, everything you need. This is I think came after PyData, which basically did the same. So they're rebasing everything on this skeletal package, which has all of the nasty things you don't want to maintain, which is related to Bootstrap. PyData, I think they're working on it right now. They're basing that on top of that, which is doing a whole bunch of their code.
Is that a Sphinx theme or like a node thing?
I think it's a Sphinx.
Okay, cool.
And then book theme are based on PyData, but then they have to go through their own refactoring because they were originally based off the original PyData theme, which has all this extra stuff, which they had to override, and now they have to override because it's the other theme. So this is a long list of things that are happening, but there's so much that we can't use the theme right now.
Yeah, SunPy rebasing our theme.
Understanding of shit that I just know that I'm never going to be able to like get deep enough to understand fully.
Yeah, we want to use the Sphinx book theme, but that's step like 256, and the first 254 of them have nothing to do with us.
Right. And so what made me pick the book theme, other than the look of it, was that there was a work in progress PR adding a feature that we would need for our thing. That they were just interested.
That's the header bar, right?
Yeah, the header bar, but also the front page. They added there was a pull request because we have the front landing page of our. But everyone who doesn't know about documentation, our website is a Sphinx project. Right? It is a Sphinx. It's a Sphinx static website, right? Yeah. Instead of like any of the other static Python libraries, we settled on writing a website in Sphinx.
Because we're absolute lunatics.
And so our landing page is like a bit of custom like HTML override of Sphinx to get it to look like that. They are implementing that themselves in the theme as well, which makes everything much nicer.
We may want to consider using Jupyter Book as the config for the website, as opposed to the base Sphinx. It might be worth experimenting with.
I think there is a case for if we actually like executive work, we should actually just Jupyter Book. We should actually.
I don't know which it's.
And we get the name.
Can
We should consider. We should probably consider maybe migrating everything eventually, but that's a larger project. But maybe something to consider in the future because
At future coordination meetings.
Okay.
Does anybody think it's coffee time?
Hey, folks, they got us.
And
Speaking of what's the schedule now?
It is.
cloud computing?
PyPy download sites. Yeah. A-blogs download.
Will talking about cloud computing.
Almost half of SunPy.
Yeah.
Right?
Yeah, okay, cool. Let's go, let's get out of this CO2 box and
Okay, everyone, I think we'll be back in half an hour. I don't know. Still.
Yeah.
For supporting scalable cloud computing led by Will Barnes. Is that still
No, Jack.
true?
I think Jack.
I'm sure.
Oh, Jack. If Jack can do it, Will either too.
I don't know. So, well, there's a, the person who I wanted to be here for that is not going to be able to make it.
Which was Steve.
No, there's a guy called it's someone from God, the person who's leading like the Helio cloud stuff.
Oh, okay, right, yes, good point.
So I'm not sure how much sense
I mean, well, I mean,
we can.
that's the other thing with X-ray. We kind of get, well, kind of get all that kind of stuff.
Oh, do you know what? If that's the case, you know, we should talk about models.
Yeah, well, we get dust, right? Which
Yeah.
Typically, they said they have dust
You
already.
don't need X-ray to get dust. Like
sure, but like NDCube isn't tested with dust yet. So.
it is.
Yeah.
Are there any tests run on dust?
Yeah, in the disputable stuff.
Okay, but like, my point is that you don't have to write a whole set of new. Yeah. Well,
You don't have to check that your stuff works with dust because
X-ray.
X-ray does that for you.
What's that you wanted to bring up in terms of how? Alright, well, we've officially started now. Of like how you think SunPy can better like support or enable like cloud computing with Solar6 data, particularly like the data products that we already support. Like I mean, even things like AIA images.
Right. Yeah, so I don't have direct responsibility for Helio Cloud.
Right.
Can somebody just explain what Helio Cloud is before we go down this?
Okay. Helio Cloud is the representation of the NASA's efforts to move the data and computing to a cloud-based architecture. It's AWS based. Now, that's not to say like not all, nobody's going to force you to use Helio Cloud. But there are, as everyone knows, the cloud offers some, some advantages for particular science applications and is especially useful for like newer science applications. Like if you want to, like machine learning is the example that everyone uses because you need to you have large data sets which you can store in the cloud quite easily. But more importantly, you have large amounts of compute right next to it. And so shoveling a whole bunch of data through to train your ML algorithm is a great example of cloud use. And so Helio Cloud is just at its fundamental level is like, how do we make heliophysics data useful in a cloud architecture? So that's as I say, I don't run Helio Cloud. Brian Thomas is responsible for setting up all of that, but so he can answer more of the technical details. But that's essentially what we're looking at.
I have a question from a selfish perspective. Like how do you know? Maybe if you don't know, this is fine, obviously. But like, how does this interface to the wider community? Like if a buttload of STO data ends up in Helio Cloud, whatever that is, right? Can I use it? Like, can I use it and not pay S3 transfer rates? Like, is it in the AWS public cloud so I could pay for compute but use the data for free, or is it like, do I have to get access to Helio Cloud, whatever that means, or
you have to be got it?
Yeah, do I have to work for NASA? Like,
so the short answer is no. You don't have to have a NASA ID. The data will be made available to you. Use of that data will cost you money, but you do not have to have a NASA ID. You do need to go through
data or use of the compute. Because
use of the. No, you pay for the compute, but you don't pay for the storage of the data.
But what about accessing the data?
Access of the data will also be your costs.
Well, will cost.
Sorry?
Will or won't? I didn't hear what you said.
They will be your costs.
Okay.
Access
Because I thought,
and compute will cost you money.
I thought that if you bought AWS compute next to S3, you didn't pay transfer.
Maybe it depends on the type of S3.
Or if it's not, like, as long as you're in the same, if the compute's in the same region as the S3 store, then you don't pay transfer out of S3.
But there's different types of S3, right? So depending on how much you access.
Okay.
Yeah,
All right, fine.
there are access costs which are small.
Okay.
So the details, I'm not particularly familiar with them. So if Brian were here, he would be able to tell you. So
that was enough. It was interesting. Thank you.
Yeah, so we have people who are on Helio Cloud who do not have NASA IDs. So you don't so it should be accessible. So the reason I put this on the schedule for the SunPy meeting is that a big part of what Helio Cloud has done in the last year is create a data analysis environment, like a bunch of Python packages, and got them all together and provided that for the summer school earlier on this year. That is something that is of interest, and so that environment works. That's great. The question is for SunPy is like, how can should and how could SunPy support cloud-based science in the future, because that's where we're going. So, but that's going to be a feature in the future. So I think if SunPy, like I don't know what the answer is, but like if SunPy wants to have some relevance in that sphere, then perhaps some changes should be built in.
I mean, I think the biggest thing that, well, the most obvious one to me is that the things we do, particularly like on map, are not, well, this is very specific, I guess, but that like the operations we do on map are compatible with Dask, because Dask seems to be our kind of entry point for doing scalable, largely array operations. Right? That's sort of that's where I see the interplay.
And Dask is completely compatible running on AWS. There's no like unique.
So Dask, the base package does not care where your computation is run. It basically, all it does is take in an operation like a sum or a Fourier transform or whatever, and then it creates the DAG. So you're
sure, but the question was, does AWS care? I'm presuming it doesn't.
No, because so you can then take that DAG and then you can pass that off to a Dask cluster, and that Dask cluster can be running on AWS, it can be running on Google Compute, it can be running on my laptop, or PC machine. It doesn't matter. It's like, and then those things decide how that DAG is distributed over the system. So yeah, so I guess we just need to make sure that the things we're doing to the data operations we're doing in SunPy, particularly, I mean, map is the obvious one, because those are, I think of like you're not going to probably be wanting to do like coordinate transforms don't need to be done in a parallelizable fashion, at least. Okay, so maybe I'm wrong, but anyway, we'll leave that for now. The array operations are the expensive ones usually, right?
Yeah, but like reproject, you were saying that the coordinate bench bottleneck, the bottleneck for reproject is the coordinate transform, and that's because you're doing a coordinate transform on like a 4K by 4K by 4K cube, right? Suddenly Dask sounds a lot more useful there.
Yeah, okay. I've gotten myself, I guess. So, okay, I mean, well, okay, then maybe we need to think about that for coordinates as well.
Which is an amplified one.
Yeah. Yeah, yeah.
Well, it's our problem as users if it's like we've built all this shit on top of it and
So yeah, okay. It's not just our problem; it's also an amplified problem.
Yeah.
I mean, like the code fix might be an AstroPy, but we still have to think about that.
I wonder if that is an efficiency problem, an efficiency or an optimization issue that needs that the cloud that like parallelization can solve. And that I think that may just be a like we need to find a more efficient algorithm for either traversing the transform graph or for doing this really complicated pixel to world pixel operation. I don't know.
Well, I mean, fundamentally, though, if you've got an absolutely massive out-of-core Dask array, and you want to do world coordinate transforms, like pixel to pixel on this absolutely massive out-of-core Dask array, for some reason, reproject is the obvious one we know about, but you could want to do other things with it too, then your coordinate transform is also going to be out-of-core large. Like even outside of parallelization, like if you want to do world to pixel for every pixel for an array that doesn't fit in memory, you're now making two arrays the same size that don't fit, or two or three arrays in memory that don't fit, that also don't fit in memory, right? Like just.
Mm-hmm. Yeah, I don't have like.
So with a cloud system, though, you could just get more memory, right?
No, I mean like there could be more memory than one node.
But
right?
you have to be able, you have to have a way. I think that's what I was saying about Dask. Like you have to have a way to shove the computation into the shared memory of your cluster, and Dask is the way to do that via the DAG that it creates for your operation. Like it's, I mean, unless you're in the case where you just are sitting on like a really really beefy node that has like 500 gigabytes of RAM or something like that. But once you've scaled out to more than one, then it, that's a different problem.
So is this just a Dask problem, or is there anything in SunPy that can help?
Well, so I think one of the things that is on my to-do list as part of the Ostafel funding is to go through like the core package and probably actually, the core package, and to see whether the array, the operations that we're supporting on, let's say, well, in general, but starting with something like map, like if I pass in a Dask array to map, for example, do I get out? Is it just forcing an eager computation? So is it not giving me a DAG back? It's giving me a NumPy array back, in which case that operation is not supported by Dask. So something like that is probably not going to scale in this framework. I think that's a.
So the use of a Dask array would be transparent in SunPy, and so SunPy would just automatically use Dask if a Dask array went in.
Yeah. So I mean, really, the way it should work is Dask in, Dask out, right? Like because right now we do support, like, you can create a map by passing in a Dask array and a metadata object. But what we don't, or well, I guess we don't explicitly say this, but what is not true is that, like, for example, rotate. If I create a map from a Dask array and a metadata object, and then I call rotate on it, it will return to me a map backed by a NumPy array. I will not get a Dask array back. So in the case of, like, say I had 20K by 20K image. I don't know why you would have that, but you know, the sun at some absurd resolution in the full field of view. And then you called rotate on it, and you did this somehow like on your laptop, you would melt your laptop because, or you would just get an out of memory error instantly because it would try to actually do the rotation using NumPy or scikit-image or something, or SciPy.
It's merged.
Oh, okay. So yeah, so then there are.
So is that because of the way that rotate's written in SunPy? Is that what you're saying?
I think it's because we're using SciPy explicitly, and SciPy operations force eager computation.
Okay. So what's
So like just yeah, to put it a different way, you have an image which is larger than your memory.
Yeah, no, I
Right,
yeah.
one image, right? If you do an affine transform on that image, you have to have all of it in memory and do the matrix multiplication, right? With Dask, you could chunk that into lots of little bits.
Thank you.
And then Dask would work on each chunk by itself, right?
Yeah.
So then the way it's written in SunPy is that it doesn't chunk it, or there's no sort of implicit chunking. It's like, oh no, you use SunPy, whatever this is, we're gonna put it in NumPy array.
Yeah.
So is there an alternative to that isn't
Yes.
like explicitly chunking it yourself, or explicitly figuring out whether you need to chunk it?
Well, so for what's the best way to put this? Like for a Dask array, like a Dask array has to be chunked, right? By default, like it has to have some sort of chunking. Even if the whole array is just one chunk, you have to. When a Dask array is created in whatever way, the chunking has to be specified. For Dask array aware computations, they basically like split up that operation across those chunks. For some things that's trivial. You can imagine for some operations which might span chunks or move data from across chunk boundaries, that becomes much less trivial.
Which rotate would.
Yeah, which is like, and there are implementations of things like interpolation or affine transforms. So doing it is possible, but I think the biggest thing to me is like within SunPy, I feel like we're really getting into I'm really maybe getting into the weeds. I don't know if this isn't maybe too.
Well, I think the question is, following on from what Jack asked, is have we identified something in SunPy that is sort of hard coded to not be compatible with Dask?
Lots of things.
Sorry?
There's lots of things.
Or so rotate is one. Is that the point exercise here, is to sort of go through and like establish what those are and decide whether there's an alternative implementation that would have no difference in a laptop RAM scenario, but would have a difference on AWS. Is that what we're trying to do here, or not?
So I think that needs to be done. I'm not sure that's the best use of our time
here,
but I guess maybe the important.
What are we trying to do here then?
Yeah.
Then he's like, why are you still doing that?
Well, broadly, okay, so broadly we know that there are operations, like particularly on map, and I'm sure other places in Core 2, that do not support like lazy Dask computation. And I don't know, maybe I'm stuck in this very kind of narrow mind, maybe I have too narrow a mindset of I'm only thinking about this in terms of Dask. I don't know if we need to be thinking more.
So I think
broadly than that.
Another component. I think ultimately when you're talking about these workflows, you're talking about Dask compatibility one way or another. I think the other big component to this that is going to be a problem for solar physicists who want to do this is I/O.
Yeah.
Again, as kind of Martin was talking to earlier, I think this is really, again, an AstroPy problem. Like, we rely on AstroPy very heavily for our I/O in SunPy core. So it's going to be an AstroPy problem, and
IO.
we are working on it. And
Wait, so just to clarify, IO, you mean like opening up many, being able to like lazily open a FITS file?
yeah,
Well,
you
okay,
could
so maybe that's really
read
specific
small
examples,
chunks out of a FITS file. Like the PR that Martin was talking about in AstroPy, and I linked in the SunPy coordination channel earlier, AstroPy PR 13238 is, that's a terrible way to read the number, but whatever. Allows you to use FS spec, almost as bad as PSFF file. You use FS spec to read byte ranges out of a FITS file over HTTP. So like you open a FITS file that's in S3 and you want to read 5 pixels, it goes and reads 5 pixels over. It doesn't download the whole file. It just passes the header, knows the byte offset of your 5 pixels, and then transfers you the 5 pixels plus some read overhead. So probably more like 5 megabytes, but whatever. And I think there's still that makes things better, but then there's still like questions about, well, what about loading a FITS file into a data array? What happens when you have a tiled image compressed FITS file? Like Martin was saying, they're quite rare, but actually in fluid physics, they're really not. There's AIA. Like all of these other IO problems. And then when you get into like wanting to do time domain analysis with AIA, for instance, where each frame is its own file, then you also get into IO problems of now I need to open 100,000 FITS files and everything is on fire. Like, so I would highlight that as another missing piece of the puzzle at this point, or suboptimal piece of the puzzle. Maybe it's not completely missing.
So IO, a nebulous number of analysis routines on map.
Yeah.
So what else does SunPy need to either think about, lobby for, or actually do?
Coordinate.
Coordinates, okay.
I would also say, I mean,
also like delayed coordinates as well.
Delayed.
Like you get a sky coord in HGS, right, with a task array for the values where it hasn't actually done the transform yet.
Oh, okay. Yeah, fine. Yeah.
Is that so that, you know, you slice it down or something later and then you only end up computing like a smaller number? Like
I mean, potentially, but I think practically more likely what it's going to be is you then split that up over 20,000 CPUs on AWS and each one gets a little bit of it.
Right, okay.
I mean, I think another, maybe this is again kind of a specific workflow thing, but what's something that people want to do very often is get a bunch of AIA images, but they're full of usually cutouts from some specific region. You want to stack them all in time, sometimes many of them in time. We were just talking about this morning, and then do some analysis on that big data cube.
With or without reprojecting?
With or without reprojecting. I mean, ideally, of course, you know,
that was a question mark. But anyway, yeah, go on.
Yeah, but maybe, you know, okay, so maybe if you're looking at some, you know, time around like a flare, like for the, okay, this is a good example. Like for the September 10th, 2017 flare, people look at these like propagation of EUV waves right across the disk from after the eruption. You need full disk, ideally full resolution for doing that type of study, and you might only need it for 30 minutes, an hour, like relatively short time compared to something like like a 12-hour like active regional observation. So in that case, you could probably get away. Probably shouldn't, but you could stack, and the consequences of not reprojecting will be relatively small. So you might just have a data cube where just one big array full disk, full resolution. That, for an hour's worth of data, it's not going to fit in memory.
This comes back to PR and NDQ we're talking about first thing as well.
Yeah.
Yeah, quickly coming back to that, especially for that kind of workflow, having a data cube where the pointing changes,
Yeah.
it would be interesting in the stack without reprojecting if there was a way we could actually keep the actual coordinates of each pixel rather than just assuming one of them.
So if you did a slice like at a given coordinate, it would
this comes back to a WCS or WCSs.
Yeah.
Yeah. I feel like we've mentioned this before.
Anyway, it just popped back into my head because you could do that analysis and it mostly would be fine, but then at the end or whatever, you could, if you wanted to, in this frame, where is the wavefront in world coordinates, right?
Yeah.
Can I ask a question that may not be very appropriate here, but a lot of people use this SSW cutout service for AIA data where they just basically download a bit of a.
You track it.
Would it be possible with SunPy that you only download this part of the AIA file and then you with Fido download a bunch of a time sequence?
So we do support queries through the cutout service.
But it just basically goes running the cutout service. You don't do it.
Well, yeah, it makes a DRMS call to the JSOC and literally, it uses the cutout service. But wait, you're saying
instead of downloading the full 4K file, just downloading whatever patch the user requested.
From the JSOC or just?
Yes, from JSOC.
Right. We do have that functionality in some way. You can.
Well, that's the cutout.
The
cutouts. Yeah. So it uses the same cutout service that. But you're talking about if you didn't use the cutout
yes.
service. If you in SunPy you specified the cutout yourself.
Yes.
And then So I think that's a limitation both of the way the data is provided at the JSOC and also fits the way the FITS files are chunked. I don't know.
Well, a more common workflow in cloud native land is you have all the data there and you can just read that chunk out of the full FITS file.
So you had to download the full thing.
They're already uploaded into the cloud and you take your compute to your data.
Who uploads this to the cloud?
Helio Cloud are planning on putting a load of data on there. So you would pay for compute next to the data rather than bringing the data to you.
That's the whole idea behind Helio Cloud is that it's this, I guess I would think of it as it is a science platform for heliophysics, and that it's a single place to do your compute next to all data. And then there are no network. Well, there's no really network calls to get the data. It's all just there. You can treat it. Ideally, you'd be able to do some sort of search on it, but it's just there. Essentially, they're just paths to the data. In that case, actually, maybe the use case you're describing, provided you had a way, kind of like what Martin was talking about earlier, if you could somehow take only the chunk of a FITS file that you wanted, so you could do a cutout, specify the chunk of the FITS file that you wanted, and load that into a map.
JSOC is not happy if you do it that way.
I think this would have to be in a world where the data is not coming from JSOC.
You will not be able to implement a separate system from the JSOC. Until the data was somewhere else.
When you say
the JSOC would stop you.
When you say select a region in this example, are you talking about doing so in world coordinates?
Or either.
Well,
probably in world coordinates.
The workflow for that, which would work in SunPy today, right, is you check out that PR on AstroPy, which adds FS spec support to AstroPy, right? You load a FITS file with that turned on. So by giving it the HTTP URL to your FITS file in the object store, right? You construct a map from that. You still have loaded no data from the FITS file other than the header, right? It's made a HTTP ready request to get the header, or a few probably, past the header. You've loaded a map. you do submap, pick this region you want, and then you carry on, and it's only going to read out of the object store the bit of the array. That
You
select.
could actually do this on the JSOC because you could do a DRMS query to just get the URLs of the files, and you can skip. Well, you could get the header.
If you were to access the JSON
like that, they would ban you.
They will eventually. They will come.
Jack,
sorry, this has gone. I don't know if
Yeah,
this has gone off the rails.
We drove this off the rails. Yeah.
Sorry, your hand.
No, it's all good. DRMS and the JSOC will not be on any cloud platform, so
Yeah, so we are. I
you
think we are
should-
talking about two. Sorry.
yeah, you should forget about DRMS and the JSOC in the future.
And you should be happy about it.
Yeah. It's something though we'll have to replace it because things like the subsetting functions are still going to be useful. And even if you're on a cloud, you might not want all the data and you're going to have to do a subset anyway, right? If you just want to follow an active region around, for example. So that would be
Sorry, is this where Kachunk comes in? Or am I misunderstanding?
Say that again?
Is this where Kachunk comes in, which we were talking about in the previous session?
Well, yes.
Right. Sorry, yes.
I'm sorry I missed that. I had another meeting. I would have loved to have been to that one too, but I think also data formats are going to play a significant issue in what happens on how we enable science in the cloud. And I know there's already been some experiments with ZAR and whatnot.
So
as an alternative data format.
So I've gone down this rabbit hole a bit in the last few weeks and been chatting to Martin on GitHub about this problem and looking at what he's done in Kachunk, which is really cool. Anyway, so yes, to Danny's question, yes, Kachunk is actually very useful for this. So Kachunk is like a translation, as I understand it, is a translation layer from you have. So actually, let's back up a bit. The ZAR file format. ZAR is two things. ZAR is a chunking specification, like here is how you break your data up into chunks and how you specify how those chunks relate to each other, and a specification for like that chunking where the bytes are on disk, assumed string. The chunk file format is a bunch of binary files, one per chunk, and a JSON file with all that metadata about how that chunk is specified. And if you want it in one file, they zip it and send it to you. Like there's a single file format version of ZAR, and it is the broken out ZAR file format in a .zip file. Job done, right? What Kachunk does is take that, and instead of having each binary chunk of your array in a file with nothing else in it, it goes, oh, well, you've already got that binary data on disk. It just happens to be in a FIT file or a netcdf file or whatever the file was. And it's like, well, we know what those files are. We can figure out what the byte offset into that file is for the chunk of data that is referenced by your ZAR array. And so what Kachunk does is you give it a specification about your set of files, saying here are all the chunks of my AAA time cube. And then Kachunk has the ability to like know where the binary data is. It basically like ignore the header of the AIA image and know where the binary data is. AIA is an interesting question because it's actually write compressed, and that is more chunks, right? You know, each of your compressed files is a chunk. And so you can open 100,000 FITS files as a ZAR array because Kachunk knows the binary offset of the data in each FITS file, and it just ignores the fact that they're in FITS files and like makes a meta ZAR array.
So it solves this problem, right, of having to, if you already have all the FITS files, you don't have to then reproduce a whole nother data set in ZAR format. You can just use Kerchunk to expose the FITS files as if it was a ZAR data set.
Yeah.
Okay.
The caveats there are, one, you're stuck with the chunking in the FITS files you have, right? Which means if you uploaded the existing AAA level 1 products today, you would have one chunk per row per file, right? And that's the chunking you've got. You can't change it. That's what you've got. And also, you have to do some file parsing to set up the Kerchunk data set in the beginning. And that's one of the things I wanted to ask Martin earlier, but it wasn't really on topic, so I'll ask him another day. Is like how you go about setting up a Kerchunk data set over multiple files. I have a suspicion that what is currently implemented in Kerchunk is like one ZAR array per FITS file, which isn't really like as useful. You see what I mean? Like, if you had a binary table in a FITS file, you'd get one chunk per row, and like that would be your ZAR array. It would be a bunch of chunks in one FITS file, rather than a bunch of chunks in a bunch of FITS files. Into like the two-stage thing. I'm not, from a very cursory glance through the source code in Kerchunk, I'm not sure that's supported yet, but it's definitely something it could do.
If you create a Dask array from that one chunk per row, and then you do a rechunk of it.
Read from it.
Oh.
Rechunk.
Okay. Yeah.
So are we saying that Helios Cloud, in reading all the files upload to AWS, should open them all, IO them, rechunk them, save them?
But the way I would suggest, without thinking about it much harder, right, is if you wanted to just put AA level 1 on Helio Cloud, and you didn't want to do any more calibration steps to it, but you were happy to rewrite the files, I would rechunk them into like 256 by 256 squares rather than 1 by 4096 rectangles, right? Because that's a lot more useful.
Most best use ever. Everybody.
I want to study one row of something.
It's like a display on a TV.
Dial-up modem.
Then you can do interlace.
All right, so with that explanation, what can SunPy do to more support like cloud computing? Or what should we do? So I think this is a tangent of something Jack said, and I've kind of forgotten what that was.
Yeah, I guess this is my question. Is that obviously in terms of like cloud computing, there's Steve's issue where there was a bug in SunPy with setting up user configs, which
That's not a
well, it's not totally a cloud issue, but it was discovered by setting up on the cloud, which
It sort of is. You're more likely to get through the environments in the cloud than you are.
Proceed with the rest of the question.
so that's an obvious improvement. It's like, okay, well then FITS files aren't technically cloud file format. You can create with Kerchunk now. You can create a cloud style. This only works for Kerchunk.
No, it works with AstroPy, and then once that PR is merged to AstroPy, if you've only got a single FITS file, it effectively works like cloud native.
What happens if you have 100 FITS files?
Then you're probably going to want some extension of Kerchunk, and that's fine.
Because again, cloud computing for one FITS file isn't, unless it's a very large FITS file. Well, even a 16 FITS file, for example, maybe you would have that.
Yeah.
Oh yeah, I mean,
I would say also this is just kind of a small thing, but maybe even just having like an IndyCube example of creating a even just like a dummy aligned like cube, something that sort of looks like an aligned AIA cube. Make it into a Dask array, stick it into an IndyCube, and then do some operation on it and show that it returns like also a Dask array.
Yeah,
I think
that operation.
Yeah, just showing that you can do this kind of thing with IndyCube. I mean, I think that's
So as for us to learn or for us to demonstrate to users?
Yes, the second. Yeah.
Because
I'm
like
not
you
sure.
have done this.
Yeah, well, yeah, I've done this, but I don't know that we have. I think also my applications have been like pretty specific and not suitable for like necessarily and maybe like documentation. But I think like even just having an example to point people like, look, you can do this with an NDQ. Like
Is this a gallery request? Is this what this is?
Yeah.
Right. Okay.
Can I suggest like a use case? For example,
Sure, yeah.
when you have these SST data sets, no one wants to just look at the spectra. Often you want to calculate something like a Doppler shift or a line width.
Yeah.
And ideally, you would want these to be in a similar array. Like, but if you do this, like you do, like for example, Gaussian fitting to every single pixel, these operations are not simple. So I guess it's not very straightforward to do this on Dask.
Yeah.
It's not like doing an average or a standard deviation. You're doing some high-level SciPy interpolation. How would this fit in here?
Yeah, that's an issue. I think I'm not saying it's a sticking point, but when you're for certain things, especially interpolation, I think you do have to think about then especially if it's just like, yeah, as you say, not like sort of simple array operations, you do then have to sort of be aware of the fact that your data is chunked, right? And that you're what?
And how?
And so like doing things like interpolation, especially like fitting over those, yeah, I'm not sure.
So this is where like Dask delayed and map like Dask map plots and that kind of workflow comes into play, right? Like if you have an operation where you're doing some analysis per spectra, right?
Yeah.
Per pixel for all time, right? Then you can use Dask once you've opened the data in Dask, and if depending on how the data's chunked, right? Imagine you were doing this with. I'm trying to think of a good example. If you were doing it in a way where you can control the chunks, ideally what you would do is you would load a Dask array where you have like one chunk per spectra, or one chunk per 100 spectra, right? And then you would distribute your fitting operation with Dask distributed per chunk. So you would construct your Dask task graph, not like manually, but Dask would construct you a task graph where you're calling a function to fit a spectra on a 100 by 100 array.
And this can be an arbitrary Python function.
Yeah. And then Dask would go to your 20,000 AWS workers that you have got for free from NASA because they're wonderful, and be like, okay, I've got 20,000 100 by 100 chunks, one each, off you go.
Yeah.
Right? And you break the compute down into smaller sections and then distribute it.
Because, I mean, this is, for example, with Visp data, this is something that everybody's going to want to do with a velocity map. So we want to have some, either you do a fitting or do like a first moment, the centroid of the spectrum to get the velocity, and then have
That's
a map.
interesting.
Everybody's
That's one of the few times I've ever heard a solar physicist ask for like the first moment of
Really?
spectrum. Yeah, normally people are like always on the Gaussian fitting, and
no, Gaussian is terrible.
Oh, no,
Gaussian is for optically thick coronal crap. Optically thin, sorry.
Yeah, but like because in Spectral Cube, radio astrophysical Spectral Cube, there is a Dask aware first and second moment calculation. So like.
So it's already done. Yeah.
Sorry, in Spectral Tools?
No, in Spectral Cube.
I mean, the first and second moment work fine for void profiles. So in the photosphere, it doesn't work so well in the chromosphere because the profiles are very strange.
Interesting.
So I might have missed something. So does and if you pass a Dask array into ND cube, then ND cube becomes a Dask array?
No. It's NDQ has a Dask array, so it's a has a not. I mean, it's similar. I mean, just like if you pass NDQ NumPy array, it doesn't become a NumPy array. But then when it does, like when you do all the slicing, all the fancy slicing that NDQ allows with world coordinates or pixel coordinates or whatever, all that does is slice the Dask array and returns to you a new NDQ with your sliced Dask array and your sliced WCS, because it's doing those things independently.
And the infrastructure it uses is like the native Python slicing API, and therefore it uses the native Dask array or NumPy array slicing infrastructure.
NumPy array. If it quacks like an array.
Right. Yeah. So in that sense, if you put it in a Dask array, it'll do everything the way a Dask array does because the Dask array is doing it.
So does that mean like it's a kind of lazy? This is all lazily evaluated.
Yeah, because all of the Dask arrays already support lazy evaluation using the slicing syntax.
So I think it would be like, just as a first thing to get back to the scalable computing, like if we're going to use scalable computing and Dask, then just to simply say that or have an example somewhere would be great. Like it would be the kind of thing that like if somebody comes to us and say like, hey, I want to use Dask and ND Cube on Helio Cloud, but I don't know if it's worth my time learning all of this. If there was somewhere that we could point and say like, well, here's an example, and like,
Laura's right.
You can
in the Cube gallery.
Yeah, obviously. So you're talking like starting quite basic with that, right? Just like here's how you would load a fits file into a Dask array. That level, or like what you're talking about?
I think this is.
No, I'm talking about like if somebody wants to, they've already loaded data into an ND cube, but they want to know what the Dask capabilities are. It's like, is this thing Daskable? If you want to say that.
Well, if they've already loaded into the ND cube, then presumably they've already loaded into Dask or NumPy, and if it's in NumPy, then it's not Dask. And if it's Dask, then it's already Dask.
Well, I think maybe we just need an example of showing how to create a Dask array backed ND cube.
Yeah,
Right.
Yeah. So that's, I mean, that would be like those kind of tutorials of like how to use SunPy on a cloud system, and then Dask is a way that you can take advantage of the cores that are available. That would be a great start, just to show that like SunPy is already, or ND Cube, well, already supports these kinds of operations.
So we actually have already a, this isn't quite the same, but there's a, what am I trying to say? There's an example on the SunKit image, in the SunKit image gallery of how to do the time lag analysis with Dask, and showing that the implementation of the time lag calculation in SunKit image is already Dask aware.
Okay, so I think you've just volunteered to give another PyC talk. Cool. Just based on that.
Yeah.
Because I think, there would be a lot of interest in showing especially if you could run that on Helio Cloud, then to show all of that working would help get the message out that like SunPy is already, SunPy is on it, so to speak.
Yeah. So I figured I would just bring this up. This is something I did. And I don't know a lot of people, I know Jack, you've seen this, probably most people have actually seen this. This is some work I did when I was at Lockheed a couple years ago. This was actually done on the NASA Pleiades system, but what we did was we set up a Dask cluster on several hundred nodes on Pleiades. And there was kind of it was somewhat of a prototype project for Helio Cloud a few years before it was a thing, but on an HPC system. And what we did was there was actually a DRMS instance stood up at NASA Ames. So you could make queries just like you would against the JSOC, but instead of getting URLs back from Stanford, you would get paths on the HPC system. So then you would just load in the data there were no network calls to the data. It was all just there. And so this is a poster from AGU from a couple years ago, but what we basically did was we put together some examples of the kind of workflows that this enables. So one of these is, I realize I'm like zoomed way out, so I'll zoom a little bit. And of course it's not loading. One of these was actually the one this is what informed my comment earlier about tracking UV waves, is that you can load these full disk things for 2 hours. Is it at full spatial resolution, stack them into a cube and do like running difference images on them, like on the full disks, you know, in like a minute and a half, and watch. You can make a movie and actually watch the UV wave propagate across the disk in these difference images. And I think what I did was I did not do any like reprojection or alignment. I just did like what we were talking about earlier, just like stacking and pretending that nothing's moving, basically. But for these cases, the coordinate information is actually not that important. All you really want to do, like, sorry, Stuart, all you really want to do is like, and well, actually, that's not entirely true, because you might want to say like, what are the world coordinates of this wavefront across the disk, and then
that's how you figure out.
Yeah, so true. So actually, I lied. For making nice movies, it didn't matter.
Right, yeah.
Which is all I was
doing
doing.
science, however.
Yeah. And then this is the other one that I was talking about. So people have probably seen these amazing color maps here, the 80s bowling alley color maps. These are this time lag analysis where you can, in active regions, you can basically estimate cooling signatures of structures across an active region by looking at how plasma is cooling relative to two different AIA channels. We do cross correlation. The details aren't important, but basically you need sort of order 6 to 12 hours of data to do these. And if you do this using the kind of usual AIA SSW IDL machinery, this can take like hours to days, depending on how many sets you do. You can do this whole procedure like from a level 1 unprepped all the way through to like this plot, which you would put in the paper in so in this case, we did it on 1200 cores and it took less than 30 seconds, right? So this is the kind of stuff that allows you to do, like straight from the stuff that comes off the data provider into your paper in, you know, less than a minute. The other applications, so this is a fun one, actually. Stuart and I did this at one of the PyHC meetings, like on hack day in the afternoon, and we went straight from, we did, what did we do? The HMI maps at a 1-day cadence for the entire SDO mission. We applied a sunspotting algorithm to every frame, and then we went from that to creating a butterfly diagram, like all in a dask where like a bag of this entire operation from the raw HMI data again to these plots, and just distribute that out to Dask. And I think we did the whole thing in less than
660 cores in 2 minutes.
2 minutes. Yeah. Tracking sunspots in every, an HMI magnetogram per day. Or no, sorry, these are not magnetograms. These were the continuum. Yeah.
And like, just like, how involved is it? Like, it takes 2 minutes to do this, but like, how long does it take, or how intricate do you need to get into like setting up your DOS setup, right?
It'll take a month to set up and 2 minutes to run.
Well, so I will.
Once you set it up, can you just use the same?
Well, so the first time Will and I did this was at SunPy in 2018. The weekend-long sprint at SunPy in 2018. We were in the room with like Martin Durant and God, what's his name?
Matt Rocklin.
Matt Rocklin, who like started Dask, and a bunch of other Pangeo people. And they were like, we really want people in other domains other than geophysics to like come test our stuff. So Will and I were like, sounds fun. And why can I not remember names today?
It's the CO2.
No, yeah, it is. Who put the data in the cloud? Mike put it up on the Pangeo cloud for us before we were there. And we went from, I don't know about you, I'd never used Dask before.
I have.
That's
where this is where the use case came from.
So I hadn't really used Dask before. Maybe played around with it a little bit, but
I had used it on like either my computer or like the big machine that we had at Rice, which is all just like one big beefy machine, not on a distributed system.
And we, in the space of like a day and a half of dev sitting next to each other, we went from, okay, here's a buttload of AAA level 1 data in Google Compute Cloud to having prepped, calibrated, stacked, and done real-time lag analysis on like terabytes of data. What do 12 hours full cadence, all passband?
Yeah.
So we went from 0 to functioning in a weekend, like in 4 years ago.
Yeah.
So, but yeah, to answer your question, Laura, the setup can take some time, but also the advantage of Dask is that the code you write is independent of the thing that's like of where it's running.
Yeah.
So you write code, sometimes not even really against Dask. Like ideally, you write code in the same way you would sort of you would do like NumPy operations, and it just happens to be like a Dask array instead of a NumPy array. That's not always true, depending on whether your stuff breaks down into actual array operations or not. But regardless of kind of what the sort of the backing compute infrastructure, if it's your laptop, if it's a cluster or whatever, that code should look the same.
Yeah.
So like it's like in this case, like here we're actually setting up a cluster on top of this job scheduler on Pleiades.
Like that aspect is really, really important for usability, because it
Yeah.
means you can develop the code on
Yeah.
like a few hundred gigabytes of AAA data on your laptop, and then once you've got that working, you go on to AWS where you'll build per second for the CPU, right? And go for half an hour, and you get a result, and you've got like once you've got the cluster set up, it's like what the wheel's showing here, done. The code is the same.
Yeah.
So you have a very good expectation that it's going to work, even though you've just like gone super wide, right?
Yeah. And like say configuring your cluster or whatever, like how much knowledge do you have to have about distributed computing to do that? Like, is there an optimized thing for that? And is that the thing that takes the most time for like the usability point of view, right? Yeah.
So that depends, but I think ideally from the Dask perspective, you need to have sort of the most minimal knowledge possible. And so like in the case of cloud computing, usually you would depend on the administrator of your system to kind of have most of the details worked out. And you yourself might start the cluster, but like how the rules for how resources get provisioned on that cluster are kind of handled on the admin side.
Okay, like taking Helio Cloud as an example, you'll just basically be able to import a thing and it'll start.
Yeah, I tried to stand up a Pangeo instance before to do this kind of stuff myself on AWS, and it's definitely not trivial to do like from zero.
Yeah.
Or at least it wasn't when I tried. Maybe it's gotten better now. But
yeah, that is changing. I think the Pangeo folks have put a lot of time into making their kind of full stack more deployable on many other systems. But you know, it's never, like setting up the infrastructure from scratch is not going to be trivial, but I think you often don't need to do that.
Okay.
Maybe that's, I don't know. Yeah.
Yeah. I guess it makes it less scary. I know that sounds silly, but like you're like it's accessible if I kind of
So like, well, this is one example. So here, this is the stuff running on top of the HPC cluster at Ames. So the HPC clusters run this job scheduling software called PBS, and that basically is a way to it's what scales your jobs out across their system. Dask has a library called Dask Job Queue that is specifically for setting up Dask clusters on top of schedulers, which is kind of like an evil thing to do. Like it's basically hacking an HPC scheduler to be not what it is. And so what it does, well, it's not important, but basically this is the one line that you do. You import PBS cluster, you start a cluster, you pass it to the client, and then ultimately the rest of your code does not care what this client is. This client could be local client, like on my laptop. It could be like it, but here it happens to be the PBS cluster. And then from here down, it doesn't matter what it is. You're just like sending work to the client.
So from a lot of this conversation with we're kind of talking about, oh, how do you do this in Python? I'm not really hearing a lot that SunPy needs to do to support this. So is it true to say, oh wait, SunPy's good, we're done? Like now we just go like have people learn how to use other tools.
You can, and you have been able to for years, use SunPy to do these workflows at scale in the cloud.
I did this on pre 1.0 SunPy. I mean, yeah.
Right, okay.
But that doesn't mean there aren't things we can do to make it easier and faster and more efficient, and just better.
Yeah.
Right.
So what are those things?
I think it's the stuff that we've already said. I think it's the IO issue. I think it's making our kind of existing operations desk aware. I think it's examples and like showing people. And
Sorry to cut in. I was just about to say, I think if you are to
Don't always sad we're not crafty better.
yeah.
Sorry, Bruce.
No, sorry, no, just cutting in. But I think Will is right. If you are to bring this in, examples will be very, very useful for sure.
Yeah.
I mean, so I was able to do this stuff several years ago, but I will also say that I had been already using Dask. Okay, for one, obviously, I'm fairly familiar with SunPy. I had already been using Dask for years before that, and it still took me it took me 6 months to make this poster, right? Like, so it's not a trivial. Like, I don't want to say this is a trivial thing, and I think especially if we're trying to sell people on Python, if we showed them this notebook, they'd be like, whoa, you know. It's yeah. I mean, like, so I don't think the tools exist, but I think we still need to kind of work out the rough edges that exist between us and things like Dask, and then to also provide examples of showing like how you can do this.
Okay.
Yeah.
All right. So then, what else do we want to achieve in this session? Sounds like we've identified those things to the point we're going to identify them today. IO examples and like some of those analysis methods that force us into NumPy rather than or support us into memory.
Yeah.
Well, I mean, two things were said. Two things were mentioned at the start of like coordinates and reprojection.
Yeah.
Those are big, right? I don't like. Does the coordinate stack? I mean, how would you transfer like 100 million coordinates? Like recalculate them? Is that easily Daskable?
Yeah, that's a good question.
Is AstroPy coordinates easily Daskable? Was that the question?
Yes. AstroPy and Dask have many incompatibilities. Yeah. So even stuff like quantity hates Dask arrays. Like you cannot have a quantity backed by a Dask array. It does not work.
No. The answer to that question is a resounding no.
Yeah.
That's a great point. Because like it's the start of your workflow. If you need everything to be reprojected to a certain point, you can't do that, and then you can't do what you need to do. Right?
You can, as I was saying, like to Diego earlier, you can break down any problem, Dask aware or not, into bits and parallelize with Dask a chunk at a time.
Yeah.
So if you wanted to reproject an entire stack of AIA images, as an example, you would do one AIA image per node in your Dask cluster until you had them all done. Yeah. Right? Okay. So that's what we did back in 2018. It's what a lot of the other examples we were just showing you. They apply functions that aren't Dask aware one chunk at a time.
No, more or less. It's not. But the thing is, it requires you to kind of have a knowledge of the fact that you're running on Dask. Whereas opposed to like the time lag analysis example, like it is the exact same code that you run. You run on a NumPy array and it works. You run on a Dask array and it works. And really none of the code is Dask specific. It just works because it's broken down into array operations that are natively supported by Dask. Like as opposed to these other things where it's just like you're having to apply them sort of one at a time in a more manual fashion. Dask supports both, but of course it's better to do the things that when your workflows look just like they would on a NumPy array. It's just backed by something that's distributed across, 50 nodes.
Or even just the 4 cores on your laptop.
Yeah.
That's the real power of Dask, is that if you've set up parallelization with Dask, it basically transparently scales from 4 cores on your laptop to 10,000 on AWS.
Okay, nice.
Sorry.
Yeah, I've done that from my laptop to my desktop using Dask, and even though like it's not a factor of 10,000 jump, like the speed up is obvious, and the programming is 0 to I think I changed one number, which was just the number of cores. But anyway, to get back to the like, so Laura originally said that, you know, if you say you got 1,000 images and they all have to be reprojected to the same point of view, then you can spread that over 1,000 cores, right? To do that reprojection, but the reprojection itself, that calculation is going to go slow on each of those cores, right?
Yeah, it's not fast. So yeah, I think there is work certainly to be done. Sorry, I cut you off. I'll let you finish.
No. So I think like it's not like the full SunPy stack is not completely Dask aware or Dask compatible. You can take advantage, like on the science level, like on the science goal level, we can provide advice about how to, you know, for common tasks, how to split them up and take advice on Dask, but the full stack is not Dask aware.
To some extent, that doesn't matter.
Well, I think in terms of promoting usability, it does.
Why do you say it doesn't matter, Stuart?
Well, because you can still use the functions that aren't Dask aware with Dask. Like sometimes it isn't as as good as it could be, and we can make improvements. But I don't think that turning around and saying lots of SunPy isn't Dask aware needs to that will just scare people off. It's not.
There is a fun bug in AstroPy where if you have a function, like if you call a function and that function is supposed to return an AstroPy quantity, it will return a NumPy array. It will not return a quantity, even client.map, client.submit. So it's not entirely true. I think because of edge cases like that, there are cases where things still don't.
There are always bugs.
Yeah. I'm just saying.
So I think even if you don't need to write any Dask code in the implementation of SunPy, if we want to say we support Dask arrays, we have to run our entire test suite on a NumPy array and a Dask array.
Yeah,
I don't think that's true, because
how do you know all of our stack works with Dask if you don't do that?
Because it doesn't. All our stack doesn't have. That's my point. More of my stack doesn't have to use Dask. Dask arrays underneath still use NumPy. So, per chunk, a Dask array is normally a NumPy array, or it's a CuPy array or something if you're being really fancy about it. But normally, it's a NumPy array. So if you're taking an array of 10,000 AIA images, one spatial slice per chunk, and you want to do rotate as it is today, our code works with Dask because we've tested it against NumPy.
Yeah, but working means something. Working, you could say I put in a Dask array and I get something out that's correct. But working in this context means I put a Dask array in and I get a Dask array out, and that's not the case for us here, right?
Really?
If for rotate, right?
You don't get a Dask array out?
No, you get an
No, you get an NumPy array out because it forces the eager computation. So it immediately kills your Dask lazy workflow.
Yeah, and
Right. Yeah, that was said earlier, but I didn't quite understand it.
In the situation where we have things that are Dask array, Dask aware, obviously we should test them with Dask.
Yeah.
But my point is that we don't need to we are not going to be able to make everything in SunPy Dask aware, but that isn't necessarily a major problem. Yes, some stuff would be better if it was Dask aware, but not everything is. Not everything needs to be, and not everything can practically be made Dask aware with the resources we have available. And that doesn't mean that we need to be particularly pessimistic about our Dask support, because you can still do lots of very useful things with.
No, but I think it means we need to be careful about being like selling, I think you need to be careful about what SunPy is compatible with Dask means.
Yeah, I agree. Yeah.
So you say SunPy maps in this context are compatible with Dask, not SunPy.
Well, there are aspects.
Yes.
Like
yeah.
submap, for example. Submap works great. You can call submap and it will return to you a Dask array crop to that particular region. Amazing. If you call rotate, it returns to you an umpire.
Yeah.
So imagine someone asking the question, can I use Dask with SunPy? Right? The answer is going to be, it depends, right?
Yes, asterisk.
Yes. Can I?
Well, I
can
think-
I
Yeah,
do
but what,
use Dask for everything? No.
I think part of the problem here is that Dask is not one single thing.
Yeah.
I think what you're talking about more than what I'm talking about is Dask array,
Yeah.
right? How much can
Yeah.
you use Dask array with SunPy is significantly less than how much can you use Dask with SunPy. You can use Dask with a lot of SunPy with Dask in terms of delayed, the task graph, the distributed scheduler.
Yeah.
Dask array, on the other hand, we have minimal support for Dask array in SunPy at the moment.
Yeah, I guess probably we should have, if I had actually been prepared for this, we should have defined that,
Yeah. So if you go to the Dask homepage, the top line is Dask is composed of two parts: dynamic task scheduling and big data collections, which is Dask arrays.
Yeah.
So, yeah, I think Stuart's saying that SunPy will always be compatible with dynamic task scheduling.
Yeah.
But
that's which is the harder kind of thing. It places more burden on the user, but yeah.
I suggest that we think about what more we want to get out of this conversation today, because we said we wanted to do a little bit of pre-hack planning.
Yeah.
And both the clock and the CO2 monitor are pushing against us a little bit.
Yep. Jack, would you have any last?
You have a
last things you
CO2
wanna
monitor. Why do you have a CO2 monitor in your room?
It's almost
Because
red
all rooms
in ours.
here have them since COVID.
It's real
Oh, I
bad.
see.
So
It's been very angry the whole week.
It's coming in and it's still green, and it's got progressively angrier the longer we've stayed in the room. So
You're just breathing too much.
that's it.
yeah.
Got too much hot air.
Yeah.
That does.
I do think though, like on this topic, like a lot of people have used SunPy to do cool machine learning stuff. Like maybe we should like ask, right, and like poll people or ask people in within FDL and things like that, that like what issues did you have with trying to do this?
What did you do?
Yeah, or like what did you do and how did you deal with these issues and what would you like to see going?
Or what didn't you do because you were
Yeah.
hampered?
Exactly, yeah,
It's probably a more
yeah.
Well,
interesting question.
this could be asked to both you and Shane. Like,
Yeah, I was gonna say I could tell you what didn't work and why, but it wasn't necessarily a SunPy issue or anything. It's just that the team that I was on was sponsored by Google Cloud, and I was like, oh, I want to spin up like a Dask cluster. I want to do X, Y, and Z, and they're like, oh no, but you can just use this Google tool to do that rather than using Dask and non-proprietary stuff, and they just didn't want to help us do that. And so we ended up just like basically setting up really, really big, beefy VMs and just doing like really stupid processing on those VMs, not in parallel and not using Dask or anything like that. If we could have, I would have. So, yeah.
You couldn't, so you didn't. That's fair enough.
Yeah. Like I know Raph, like he'd be like, oh well, sometimes I couldn't do that, so he went and did his own thing.
Yeah.
But I wonder what that was, and maybe it could, and what would you have liked to have seen there, what wasn't documented well.
That's I think that's the most frustrating thing is when people encounter these they're not edge cases, these incompatibilities, and then they don't bring those up, and probably because they seem quite specific.
It's gone red.
Oh no. But then I mean we can't know about them if they don't tell us.
Sure.
So,
Yeah.
Okay. We'll put a note down that there should be something to be considered.
But like even like asking on Helionauts, I mean, like, what did you find? I'll do
Yeah.
that right now.
Yeah.
Actually, it's tomorrow, so I might say something.
All right. Is there any? Yeah. No. I'm just trying to get. I'm not saying we should like stop if there's something more important. I'm just trying to basically get a list of like what do we still need to achieve in this, because I think there's some people are getting tired, and one thing that happens is we just keep talking.
God, it's already 5:05.
Right, yeah.
Yeah.
So what more do we need to, what other things on an agenda, if we were to invent one now, need to be talked about? Or are we just sort of talking about Dart?
I think we spent the last 2 hours talking about that.
Just talking,
Yeah.
not sort of getting out what we need to get out of this.
I like the notes. I think there's stuff there, so I don't think this is. You haven't wasted your time from my point of view. So thank you.
Oh, I don't think we've wasted our time at all. I'm just saying.
Do we talk about anything else?
Yeah.
Or do we, this conversation need to continue tomorrow, isn't it? Or
I'm good. You should go out and get some oxygen. So,
sweet.
Yeah.
Before we go get some oxygen, we should do a bit of sprint planning tomorrow.
Yeah. I mean, I think we have a good list of to-dos in the notes.
Great. In that case, thanks to all those who contributed. I certainly learned something.
Yeah, if people remote are interested in participating in the sprints tomorrow, hang around. Otherwise, I don't think there'll be any more discussion outside of that today.
What was the models thing? Quickly, just.
Oh, well, that's not going to happen.
No, that's not happening. I just wasn't aware what it was.
Oh, yeah, we're just talking about putting, basically, Laura and I want to advocate for putting X-ray emission models into a more well-known and centralized place than some expert. Or we want to explore that possibility and where that might be.
Yeah, we could spend well, I don't know if we want to take up tomorrow to do that.
Thanks, Darren.
I mean, we could spend, I don't know, like half an hour.
We could talk about it in the pub. Like it's.
We could.
I'd say it's a pub discussion, and if it's like we could talk about it tomorrow. If it turns out the pub discussion reveals that this is very important.
I'm very interested in this too.
Yeah.
So I would like.
Yeah.
And like even if that could be scoping out, like I think sitting down and trying to figure out what would go into something like that is a hack thing that we probably need to do. Yeah. So.
And we're going to go to the PAV, which is literally a field, so there'll be lots of oxygen to think clearly.
Actually, yeah. Okay.
Yeah.
I'll put that on the hack day thing. Right?
You don't understand how unbelievably jealous I am.
Oh, sorry. We'll send you a picture.
Yeah, that'll help.
Yeah.
All right.
All right.
Sprinting.
Scope. Okay. If you're on the notes document, if you scroll down, there's all the hack day ideas.
Can we plan on the whiteboard?
Then people online can see.
We should get the stick.
Oh, yeah. Okay. All right. Yeah. That's fair.
Do we have a picture of this?
Yes.
Yeah, they're in the chat.
I don't know what this.
Or if someone does just want to share their screen, just so we have one thing to look at, then that's fine as well. Yeah.
I don't know. We can do whatever. But my computer's about to die. So.
If someone wants to plug it in, we'll put the whiteboard here.
I think
We plug this into your computer.
John.
Activate cam on a stick.
I think we had it on the other side. That's fine.
Yeah.
I know it's
So
Right, it's not gonna
we
go
do have a
down.
picture of this then, right?
Yeah.
No more logo.
I might join you later in the pub. You need
Sounds good.
to send me maybe on the chat.
Yeah,
Yeah.
it's the address. Yeah.
Just
Yeah.
about that.
Sounds good.
But before I forget, thank you
Oh.
for giving my camera lens.
Oh, I appreciate it. Thank you.
This is the most Norwegian, like, it's basically Kit Kat. but it's a-
Perfect. Well, thanks. I appreciate it. Yeah, this is a great return on my investment.
It's not showing up on there.
I think Nabil needs to share his screen, right?
Oh, no, I share my screen.
No, you need to.
Oh.
I think my mind's video.
That's probably just this machine melting. I can tell you whether it's turned up on YouTube. It has not turned up on YouTube. Refresh your.
I'm actually going to head off here, guys. I'm an hour ahead. I just want to go home. But I'll chat to you tomorrow.
No,
See ya.
See you all.
Thanks, Pierce. Ah, for that. All right, now, I don't actually know what we need to say or plan, so if someone just tell me what's correct.
I guess it's like who wants to do what and who what. I need to go.
ND collection PRs.
Yeah.
Should we,
Market.
Yeah.
should we group this?
File doesn't want to load.
No? I think like having an ND-ish.
It's good.
Yeah, because there's a lot of indie.
I think every hack is ND.
This appears to be actually in the WCS lib. C layer.
What is more like after
It won't like pass the WCS information out. It's a much lower level problem than the previous bugs we've encountered.
So this one is the same pipeline, but it's a different instrument.
Yeah.
And it's also, this is the transposed version. Not sure if that would, I can try and run it in my workstation with a non-transposed version.
Yes.
See if I get the same
Let's
error.
call that arithmetic operations.
Or double.
So the data dimensions.
What are you saying?
Double underscore.
It's like add, it's like double underscore add,
Just
double
leave that
underscore
as a C
subtract.
thing,
Okay,
or
that's the
different
input there.
What do we?
I keep thinking you're.
Are we just going to list everything that's on the hack diary on there, or are
Yeah,
people taking ownership of these?
Yeah, I think that could be the problem.
So do you want to take that?
Yeah.
You want to work on that?
yeah.
Is this how we're doing it? But like,
I don't.
I'll have a look.
What's the point? Who suggested planning this?
Stuart.
What? How are we planning
We
on the hack
base
day?
like group by importance. I'm worried if you don't do at least one of the figure papers tomorrow, we will not do this paper.
Yeah, no, you're right.
What?
But I feel like we're just now rewriting the list of the ideas on the board, right, rather than planning.
No, we're selecting the ideas and
Okay,
saying that we're
alright,
going to do these.
So
Right,
I
isn't that the idea?
think we're not gonna get too many things done, probably, right? I think I personally would like to prioritize things that
To be accomplished.
A can be accomplished and B will benefit us all being in the same room together. Like we've got a bunch of ideas on here which we could happily do over the internet, right? And they're just like some of them are bloody admin tasks, right?
But also, I think as well, like for me personally, actually, like just having a day blocked out to do stuff. Like even though they're admin tasks, I'm much more likely to do them tomorrow in this room.
Yeah, I know, but I'd much rather. There's also a bunch of stuff on here that I'm much more likely to do tomorrow. That's fun and can use the fact that we've got 10 brains in the room rather than one.
absolutely.
Okay, so I said prioritizing group hacks here, and then if someone wants to go rogue and sit in the corner, then that's totally fine. Yeah.
I would say IndieCube Gallery is definitely one of those things, because I think I benefit a lot from having you two in the room at the same time while I'm doing this.
Agreed.
Yeah.
We have like Sphinx gallery knowledge and users and everything like that.
Or like, how do you do this in ND-Cube? Let's write an example.
Exactly.
Yeah.
Yeah, I'd say this one as well, because
Yeah.
want to get Marcus like to
Yes.
off, on base when it comes to
Hacking on the figures for the frontier paper is also a good idea because we have a disparate set of experience in the room with like orbiter data and PFSS and SunPy and
I guess the medicine.
I'm going to get Ostoppel PFSS then.
He's just going to slowly drive me out of the project where I'll be able to say any of the words.
Who's gonna be involved in this at the cost of other things? Because sure I'll be involved, but at the cost of other things, and not doing something else. Who's going to be involved?
I'll make. Well,
You should be involved.
I think I missed. I'm happy to make one of the figures. Basically, if it's a PFSS figure, I'll make it.
Okay, all
So
right.
put me down.
I think we have a rough plan for what that figure will look like, right?
Yeah.
So that should be, I think.
And I've probably got code to generate 90% of it somewhere.
Yeah.
Anyway, I'll do a figure.
All right, great.
I'll have a look.
Do we want to do?
I'll have a look.
The other thing I want to do is make a list of fundable SunPy projects.
Yeah.
Which I think will benefit.
Yeah.
Can we also discuss maybe the roadmap while we're all in the room?
Actually, that's a good idea.
Because we keep arguing with, I
Maybe
feel
like
like,
try to do
obviously
things
Steve
then.
will want
Yeah.
to, like, but I feel like we need to hash it out.
Would
We need to hash something out, so Steve, because I think, my impression of PR, Steve, kind of the wrong angle of the PR.
I think maybe a few of us and Steve have kind of a systemic disagreement about that. Maybe.
Or maybe we just,
Wednesday?
maybe we need to just get Steve in the room.
given that Steve's remote anyway, maybe a community meeting
Yes, yeah.
focusing on the roadmap is a better idea.
Retired.
So not roadmap, okay. So just, I'm gonna put it up.
You'll put my name next to that. Yeah, well, I want to lead that. But it will definitely, I'll ask people various bits and pieces.
Yeah, walking around the room and saying,
Yeah,
I need
yeah,
10 minutes of your time to talk about this.
Like, yeah.
Okay.
Do you have 10 minutes of your time to talk about money?
No, just like write 2 sentences about like, if you had 6 months of time, what would you do with NDQ?
So one of the things I wanted to get out of the roadmap was kind of
Yeah, well, so I said that because I think what Steve ended up doing was not that for the roadmap.
I agree.
And you think the roadmap should be that?
Yeah.
We've rebranded that, so that's going to happen.
Well, should we just do that in one form?
I was going to say, we could hammer that out, and then when we have a roadmap discussion next week or something, we can like figure out where the line between those two things is and why.
Yeah.
Cool. Someone just solved the problem by removing the CO.
No, it's there now. Has it gone down?
Okay.
Oh, it's gone up.
Oh, okay.
I put it in the middle of the room to see if we higher or lower that.
No, that's a good point, yeah.
Yeah.
Sorry, I agree.
Okay, that's me sorted. That's all I'm doing tomorrow.
Okay. Do you want to do ND arithmetic operations? You were specifically requesting that.
I'm pretty sure. Yeah, I will. So what I'll do is I will just copy straight from what's in math into NDQ, and I'll see if it works, and I'll create a PR. If it doesn't, I'll leave it, and then I'll fix it afterwards. But I will at least start that because I think.
Yeah, problems then, like, we can sit down, so maybe that'll be done in like,
I'm just
30 minutes.
looking down this list.
Yeah.
Looking down this list of hacks, it's like 90% NDQ.
Yeah. I think that.
Right, so I'll just put Will's next to this.
Yeah.
All right.
I think that links will link in for me because I want to help with this ND cube gallery. I also want to try do things like we're talking about, maybe try do radio spectra or 6 data within ND cube. How does that work? And that will kind of help kind of guide making some gallery examples.
Yeah.
I was going to say,
Yeah.
I mean, you don't have to do this now, but I mean, writing down. Isn't there already an NDQ gallery, or was that in a PR that a Sailbot has reaped?
I don't think there's a gallery.
There's a folder called gallery or examples. I think
There?
there's a. Maybe?
I don't think there is.
Uh,
I'm docs, but that would be crazy.
I would also like to work on some like branding, like putting together templates.
Oh yeah, that's a.
Yeah.
Yeah, especially because actually this is something that's the solar orbiter meeting is in 2 weeks, so we should actually be good to talk about what we should say at that and how we. That could be a good place to like start making a template for that meeting.
Yeah, I would like to. Yeah, so I would like to
write down here.
Yeah,
Templates.
That's basically it. But, so I would like to work in the gallery as well. So I'm doing that as
Shut it down.
Yeah.
Okay.
Connor and
NDQ prop.
Connor and Sam, is there anything you want to work on tomorrow in particular?
Shane Sam.
Oh my God, Shane, please change your username.
Please just change your first name.
It would be easier at this stage. Yeah.
Sorry.
I stuck in the thing to like ND cubify radio spectra, so that which kind of fits in with what Laura was saying. So maybe that, and then also, talk about what we want to do for the solar orbiter meeting, and maybe what we would have to try and get done to show that at the solar orbiter meeting.
Yeah.
I'm only around after lunch tomorrow though, just an FYI. So I'll be there at 2.
Okay.
I'll only be there from 2 o'clock on, but yeah.
Good. Okay, I think that's probably a really good place to start tomorrow, and if we have
That's more than a day's work. So.
That's like what's the building?
I'm buying stuff.
Well, yeah, like this.
That's your hat there.
I didn't have Amazon.
There's also like NDQ with math and like the meta stuff. So,
Yeah. There's only so many hours a day.
Yeah, we could. I haven't put my name next to anything.
We
yet,
could do
because,
a proof of concept NDQ versus map without meta. Like, meta is not happening
separate
tomorrow.
things. Yeah, well, I mean, they're separate hacks. Yeah. Okay. So.
One does not simply program meta in an afternoon.
So
See you
do you want
tomorrow,
to be associated with that, Stuart?
All right, see ya.
Yeah. Say that again, Danny?
Do you want to be associated with NDQ with Matt, Stuart? Presumably.
Yeah. I think the first thing I'll work on is gallery. I can get the gallery infrastructure up.
Okay, well then while you're doing that, I can work on the vendor stuff.
Yeah, we'll do.
Yeah, and then we can, once you have that in, then we can start actually putting examples in.
Tomorrow, Stuart gives me all gathering numbers, access, and I'll just tidy up everything.
Who wants to do that?
You guys can try stuff and then I'll clean up rooms. So NDQ pack day. When do we, at what point do we just rebrand as the NDQ coordination meeting?
Jitsi has found market. Just market.
Following you around.
So I should